Hey my dear warriors, welcome to the next session of your crash course for all the JEE 2023 warriors, also open for the JEE 2024 warriors in case you want to revise the 11th standard syllabus. So this series is for all the students who want to nail the JEE Mains April attempt or want to revise the 11th standard syllabus. With me, Shreyas, your physics master teacher. Hello Arun, Shaku, Kalpana. Welcome Jayalakshmi, welcome Riddhi, Muthu. Welcome Rakesh, Namaste, Vanakkam, Bonjour. Nice to see all of you this lovely morning. Hello Blessy, hello Jitendra, hello Arun. And in today's session, what we are exactly going to do, I'll let you know guys. Some of you might be new to the channel, some of you might be probably very old and long-term subscribers. So welcome aboard. My name is Shreyas, your physics master teacher, training kids for a very long time. And my whole aim and ambition is to make sure that your marks improve no matter where you are, in which situation you are. Even if you are feeling very low, trust me, these sessions are going to help you with your competitive exam preparation. So we are going to start with short notes. Short notes I have already given to you. Where? In the Telegram channel. Where is the link? Is there in the description box. Join the Telegram channel. The next thing, I'm going to start with a brief revision of the theory. Okay, it is not going to be long, but it's not going to be very short. It's going to be probably max to max half an hour. Okay, so take that theory, understand, revise, recollect. Then we'll go to problem solving. There will be lots of tips and tricks which I will be giving during the problem solving session. Also, you will revise the theory along with the problems. PYQs towards the end. PDF you will get towards the end. And I will also give you an assignment which will be posted on the Telegram channel, which will be a part of the PDF, which is also called as your daily practice problems. If you are loving all these things, you know what to do. First of all, subscribe to the channel if you are new, and if you are already a long-term student, you know what to do. The daily ritual, smash the like button down there. Welcome JEE 2024. Hello Riddhi. Nice to see all of you guys. Thank you for all the love from Tamil Nadu. Hello Avinge. Avengers Kevin, oh my god, what names you guys have. Hello Kalpana. My throat is 85 to 90% better. You can still probably hear the huskiness. Okay, so slowly recovering. Hopefully by tomorrow, day after, I should be perfectly fine. So let's start with Newton's laws. Now let's quickly revise all the main concepts in Newton's laws. See, the first thing that you should know is that we have your three laws of Newton. The three laws of Newton. The first one, the first law of Newton is basically completely the law of inertia. It defines what is inertia. It also defines the state of rest or uniform motion. It talks about uniform motion. Okay, uniform motion. And it also gives us the idea of something called as balanced forces. Balanced forces. Remember, whenever the forces are balanced, that means they cancel out each other. That means they cancel out each other. Net force is basically zero. Then the body maintains its state of rest or of uniform motion. Uniform motion means basically there is no acceleration. Acceleration is zero. Inertia is measured in mass. That's what the first law is all about. The second law is all about what happens when there is an unbalanced force. So if there is an unbalanced force, that means there is a net force acting on it, then that causes change in momentum. So that is the rate of change of momentum, and that's why you write net force is equal to mass into acceleration. If the forces don't cancel, the resultant force gives rise to mass into acceleration, which is also the rate of change of momentum. Right? I hope this is clear. Arvindam, I have uploaded the formula sheet, bacha. Check my other Telegram channel. I have shared one link of Telegram channel. In that Telegram channel, every PDF is mentioned. Just check that out, okay? Just scroll up a little bit, you will be able to find that out. Don't worry, bacha, I will be revising all the important theory pointers. Don't worry, okay? Start. Next important thing is third law. Next important thing is third law. It basically says if force 1 acts on body 2, then the reverse, basically the second body also applies force on the first body. So it is equal to F to 1, but they are directionally going to be opposite. Magnitude wise, they are going to be same. but they don't cancel each other. That's the key takeaway, because they act on different bodies. This is a force acting on 1 by 2. This is a force acting on 2 by 1. I apply force on Pandu. Pandu applies force on me. They are on two different bodies. They won't cancel. If the same force acted on Pandu, then it would cancel. But they are on two different bodies. That means they won't cancel. Now, you go on slowly towards the application of Newton's laws. But before that, you should have a crisp understanding of all the forces. All the forces. Yep. All the forces which are relevant to you. So let's talk about all the different forces that are involved. Come on guys, you only think what are the different forces that you have ever heard of. So you should know each and everything, because when you draw free body diagram, all these forces will come into play. The most important is the weight. The most important is the weight. Weight is nothing but the gravitational pull, which is equal to mg. It changes from place to place. Exactly. Next important force, normal. Normal force always acts perpendicular to the point of contact, perpendicular to the surface of contact. So if you have one surface here, if you have another surface here, this normal will always act perpendicular to the point of contact. And if it loses touch, then what happens is the normal force becomes zero. Very good. So some of you are also going to centripetal force, contact force. Is normal a contact force, Vritika? Definitely it will be a contact force. Yeah. If there is no contact, loses touch, normal is zero. Then obviously you have tension. You obviously have tension, which is always there in strings. If you pull something, there will be tension. If it is loose, then the tension value will be zero. Right? If it is loose, then the tension value will be zero. Perfecto. Next important force which you should know is the spring force. So if you have a spring and you extend it by some amount, then the spring force will be magnitude wise kx. Magnitude wise kx. If the extension is x, what is k? The constant of the spring. If I say the spring constant is 20 newtons per meter, it means per meter I would need 20 newton of force. So if you extend it by 2 meters, I would need 40 newton of force. So that's what it means. So that is your spring force. Then the next force that you should know. Oh, by the way, centripetal force and centrifugal force, guys, don't consider that. No, centripetal force is not a type of force. Centripetal force is not a type of force. Remember that. Many students say, sir, centripetal is a type of force. That is wrong. If some teacher has told you centripetal is a force, then they have lied to you, they have fooled you. Okay, I'm sorry to break that to you. Next important thing is frictional force. So frictional force, there are two kinds. Again, I will just probably have a separate thing for it, but before that, maybe I will tell about some other kinds of forces over here. Something like, guys, pseudo force. Yes, pseudo force is a fake force, so it is not a real force. So the value of the pseudo force is nothing but mass into acceleration, but direction wise it is opposite. So that's why you put a negative sign, but when you show in the diagram, you show it opposite to the direction of the acceleration. What is this acceleration? This acceleration is the acceleration of the frame of reference. Example, you are in a car which is accelerating. You will feel a force backwards, haven't you? If suddenly the driver brakes, you get pushed forward. Haven't you experienced that? That force is the pseudo force. In an accelerated frame, you experience a force opposite to the direction of acceleration. That is the pseudo force, which is mass into acceleration. Exactly. I hope this is clear. Another important thing is obviously friction. So I'll just come over here. So friction is of two types. One is basically your static friction, and the next one is basically your kinetic friction. Static and kinetic. Remember, static friction is a adjusting force, and it only comes into play when the surfaces are not actually moving. There is no actual motion. It is just that there is some tendency to motion. Like I am trying to push my hand over it. It's not moving, but I experience some friction. Just try it out. It's not slipping yet. It's I'm trying to push it, it's not moving. So that friction is static friction. This friction is adjusting. So the maximum value it can go to is Fs max. So I will generally put Fs is less than or equal to Fs max. Basically it is less than or equal to mu s into n. What is mu s, guys? Mu s is the coefficient of static friction, which is the coefficient of static friction. Rolling friction is basically friction when objects are rotating. In fact, rolling friction happens to be static friction. If you recollect rotational mechanics, when you show friction on sphere, disc, ring, which is moving on a table or whatever, inclined plane, that friction which you show is rolling friction. But if you think, observe and analyze closely, it is nothing but static friction. Just that the friction is little bit less than the maximum limiting value. That's why you say that rolling friction is less than your sliding friction. Okay, I hope this is clear. We are coming to circular motion and work per energy also. Yes, is coefficient of static and dynamic friction same? No. Always remember, this kinetic friction only comes into play when things start to slide. When things start to slide, when there is actual sliding motion, this friction is not adjusting, it is a constant value, it is mu k into n. Remember, mu s is generally less than mu k. It's generally less than mu k. That means, oh sorry, my bad, mu s is generally more than mu k. That means when you start sliding it, the friction reduces. But when you begin to push it, it becomes difficult to set it into motion. Once you set it into motion, the friction reduces. So kinetic friction is always less slightly than the static frictional force. Is that okay, bacha? Is that okay, bacha? I hope this is clear. Now, friction. Remember, when I say it's of two types, static and kinetic, you should be able to understand when it is static, when it is kinetic. Example, if I have a block, I try to push it, but it doesn't move, the velocity is 0, then the friction acting will be obviously static. It will try to oppose the tendency of motion, that will be the static friction. Whereas if there is actual motion, relative motion, then the kinetic friction will act opposite to the direction of motion, that will be the kinetic friction. When there is actual movement, there is relative movement with respect to the surface. If the body goes this way, friction acts the opposite way. Keep this in mind. Now, what are these coefficients? These coefficients are basically nothing but standard values. Do you need to remember that? No. Will it be given to you? Yes. Example, imagine rubber or wood on some marble flooring. They will give you the value of mu, 0.6, 0.5, 0.4, whatever. So if you know those values, you can find how much frictional force is there, because you know how much normal force is acting. Normal is the contact force which is coming from the top, correct? Into mu will give you the frictional force. Now, why is this symbol there? Because remember, it is an adjusting force. Which force is adjusting? Only static friction. Is kinetic adjusting? No. Means when you slide, the friction is constant. It is equal to mu k into n. But when it is at rest, if you push harder, friction will be more. If you push less, friction will be less. It adjusts. The maximum value is mu into n. I hope this is clear. I hope this is clear. I hope this is understood, everybody. Great. Rennie, Harleen, I hope that is clear, Bacha and Navneet. I'll be maintaining this speed. If you want to pause at any point of time, please feel free to pause, okay? Okay. Because we have to cover a lot of things, okay? Great. Now, in Newton's laws, once you know all these forces, then the main thing which comes with respect to all these forces, with respect to all these things, whatever you are learning over here, what is the most important thing? It is basically your free body diagram. It is basically your free body diagram. In free body diagram, you show the forces acting on a particular body. Maybe a mass, maybe spring mass, maybe pulley mass, or maybe something else only. Blocks on block, whatever. A person riding the bike, okay, a person hanging from the rope, anything. You show the forces acting on the system. Forces acting on the system. Do not consider internal forces. Internal force does not matter. Internal force doesn't matter. Keep this in mind. Internal force does not matter. What is the meaning of internal force? Imagine I try to push myself. The force which I am applying on myself for this body is internal force. I cannot move myself by pushing like this. I will have to push some external body, so the external body applies a force on me, that becomes external force. Make sense? Like when you are on a bike, you cannot push the bike standing on the bike. You will have to put 1 foot at least on the ground. You push the ground pushes you. The ground is an external object pushing from outside to the body, which is your scooter plus you. So that becomes an external force. Internal forces never ever consider. Also show the accelerations. Accelerations of the system should always be shown whenever you show FBD, which is free body diagram. Just to give you certain ideas of free body diagram, just to give you certain idea and the main systems which is there in Newton's laws. Just take these few examples. Imagine if I have one block M1 connected by a string to another block connected by a string to another block, and I'm pulling this and I'm pulling this. Imagine I want to find the tension in the string which is here. Let's say I call this T1, let's say I call this T2. Let's say I want to find T1. What do you think? Whose FBD will I draw? Whose FBD will I draw? Come on, think about it. Vajit, yes, PYQs will come towards the end. Go behind, I have given the exact flow of the session. Banking of road, everything will come later on. M1's FBD I will draw. Exactly. So when you show free body diagram, you will show the free body diagram of M1. What are the different forces acting on M1? One is its own weight, which is M1G. Second, it's on a rough or it's on a surface maybe. So there is a normal force. If there is friction, I will also show friction because it is moving. Maybe I can show even kinetic friction. Do you agree? Why kinetic friction? I'm pulling these blocks, so they are going like that. Friction will act opposite if it is rough. If it is not rough, then friction will not come. And tension, T1. What did I tell you? Always show the acceleration as well. So it is also going to accelerate, yes or no? It is also going to accelerate, yes or no? Now, in order to find T1, think in which direction will you make equations? Obviously, T1 is in horizontal direction. So you will apply Newton's law also in horizontal direction. So you will say in x-axis, T1 is equal to T1 or other. T1 is not the only force. Here, the net force is T1 minus friction. Think about it. In the x direction, T1 is not the only force. There is also another force Fk. So what is the net force? What is the net force? I think it is T1 minus Fk. This is your net force F is equal to mass into acceleration. What is the mass? It is M1. What is the acceleration? It is A. So that's why it is T1 minus Fk. I hope this is clear. So then you will write T1 is equal to M1A plus Fk. Fk, we all know, is nothing but mu mg because it is mu n. N is going to be mass into g. Mass into g, right? So m1 into g. Mu will be given, mass will be given, g is known. Acceleration you will have to find. Acceleration you will have to find. How do you find acceleration, guys? A is not known right now. How do you find? M1 is known, mu is known, m1 is known, g is known. How do you find this acceleration? How do you find this acceleration? Yep, acceleration will be same. Why you not taken A1? Exactly, that's the whole idea, Viram. All the masses will move together. All the masses will have same acceleration. Yes or no? So, can I not look at the entire thing also as a system? Can I not look the entire thing also like as a system? So if I take entire thing as a system, then there is only one force, which is the pulling force. There is only one force, which is the pulling force. So that pull will be equal to the total mass. which is m1 plus m2 plus m3, the whole thing into their combined acceleration. Yes or no? From this, won't I get acceleration as the pull by m1 plus m2 plus m3? And once I get this, can't I substitute it here and find the value of tension? Do you understand it? Dynamic and kinetic friction is the same thing. There is no difference. It's synonymous. They are similar meanings. Understood, guys? How to apply free body diagram, meaning how to choose a system. The choice of the system is very important. Here, initially I chose M1, but I saw I was not able to solve the problem. Why? Because acceleration was not known. So then I decided I will choose another system. So I chose the complete thing as a system. I was able to find A. So in some problems, you will have to choose multiple things as a system. Will they tell you in the problem? No. You have to get a hang of it. That's why you will see me solve many problems today. And when I solve problems, you will get an idea of how to choose systems. Yes, my two equations, now you can find it out. Common formulas which you should know in this chapter is this one. If you have M1 mass and a pulley and another mass M2, this is standard problem. The weight will be M2G here. Here the weight will be basically M1G. There will be some tension. In this case, if M2 is more, it will accelerate down, M1 will go up. The acceleration will be bigger force minus the smaller force. So M2G is bigger minus the smaller force upon the total mass of the system, which is M1 plus M2. That will be the acceleration. Similarly, if you want to find tension, you can make more equations. Like, for example, over here, I can say for this guy, since it is going down, this weight will be more than the tension. The tension will be less, weight will be more. So M2G minus T is mass into acceleration. From this, you can get the tension, but it is safe to remember the formula, which is nothing but 2m1 m2 upon m1 plus m2 into G. Many times you are going to find questions on this. Many times you're going to find questions on this. Viram, bacha log, my voice is not great because I'm not feeling well. So that's the reason why you might see my voice is a little bit husky, but it's okay. Your exams are close, so I have to put in that effort. If you don't show that support, if you don't show that energy, all this effort that I'm putting in will go waste, and I will feel very bad. Okay. Now, some of you are asking, sir, what if I had to find T2? Guys, think about it. If you had to find T2, what will you do? Whose FBD will you draw? You can either draw M2 or M3's FBD, but I would prefer M3 because if you draw M2's FBD, you need to find T1 and then you can find T2 because M2 is connected to both. But if I draw M3's free body diagram, it is only connected to one string, so T2 is the only unknown. Pull will be known to you. That's it. So I feel I will draw M3's FBD instead of M1's FBD. I hope this is clear. Very good. Now, apart from this, then in the next part of this chapter, you have something called as pseudo forces, and many students get confused in solving these kind of questions. See, understand, there is something called as frame of reference. What is frame of reference? It is point of view, POV, point of view. From your perspective, what do you see? Imagine there is a person standing on the ground. Imagine there is a person in a train or a bus, whatever. This bus is accelerating. Imagine this person in the bus. Imagine this person on the ground. These two people will see completely different things. For example, if you are considering a box which is kept inside the bus, for this guy the box is at rest, but for this guy the box is accelerating. For this guy the box is at rest, meaning the net forces are zero. For this guy, since this box is accelerating, for him it is in motion, the motion is changing its state, that means there is net force. So you can see that every time the observations, the conclusions will be different. That's why your frame of reference matters. Usually, where do you sit? On the earth frame, ground frame, which is at rest. It's not accelerating, it's not having some crazy things, or which will give you some very weird observations or conclusions. But the moment you are in a frame which is accelerated, like a train which is increasing the speed, or a bus which is braking, that frame is called as a non-inertial frame. That is called as a non-inertial frame. This person is basically said to be inertial frame. Inertial means acceleration is zero. He is himself at rest. The observer, not the body. Observer is at rest. Here the observer is moving, so that means acceleration is there. It is accelerating. In such non-inertial frame, the problem is you need to consider one extra force, and only that will give you the correct explanation of everything. Your equations will be all fine, else it will be incorrect. What is that one extra thing that you need to consider? That one extra thing is called as the pseudo force. So when you use pseudo force, then all your Newton's laws of motion equations will be correct. All your Newton's laws of motion equation will be correct. So if this frame is accelerating towards the right, the pseudo force will come towards the left. If this bus accelerated towards the left, pseudo force will come towards the right. So this is pseudo force, and the magnitude of the pseudo force will be mass into the acceleration of the frame. That's all. I hope this is clear. Is that understood, bachalo? Is that understood? The most famous problem on non-inertial frame is this one. Lift problem. Basically, two main cases you have. Once the lift is accelerating down, second time the lift is accelerating up. Imagine a person, object, whatever is kept inside this lift. In the first case, mg is down. Second case also mg is down. Pseudo force is different. In the first case, because acceleration is down of the lift, so from the lift frame, lift is a non-inertial frame because it is accelerating. Where will the pseudo force be? Come on, put it up in the chat box. Where will the pseudo force be? Obviously it will be upwards. In the second case, the frame, the lift is accelerating up. So where will the pseudo force be? It will be down. So pseudo force will be downwards. So if somebody asks you what is the apparent weight here, because mg and pseudo force are opposite, you will say it is m into g minus a, because they are opposite. G is down, a is opposite to g. Here, if I ask you what is the apparent weight, pseudo force is helping, is assisting with the weight. So hence it will be m into g plus a. That is the difference. Exactly. So understood? If it is going up, plus. If it is going down, minus. Simple logic, guys. And of course, somebody is asking, what about free fall? If this lift falls freely, then what will happen? If it falls freely, come on guys, what will happen? The apparent weight will be zero. You will feel weightless. You will feel you are in space, you are floating, because the pseudo force will perfectly cancel the weight. That's it. Air resistance is never considered, Viram. Even if it is considered, it will be considered as a simple force. Like they will give you the force of air resistance is 1/10 the weight, is 10 Newton, is some function. They will give you the value, and then you will solve it by simple free body diagram, nothing else. Okay, understood? Clear? Also, remember guys, few more things, like when you have a block on a block, or a block touching a cube or some sphere. All these times, you know, many students make some kind of silly mistakes. For example, you know, imagine if I have something like this on a wedge or something like that. If I ask you what is the free body diagram of that sphere, okay, of that sphere, there will be one weight, there will be one normal, there will be one weight, okay, I can just call it M1G, there will be one normal, like this. If I ask you what is the free body diagram of this wedge, then what are the forces? Observe, weight of the wedge, so M2G. From the bottom there will be a reaction by the ground, I will call it N2. Because there was N1 on the sphere, on the wedge, there will be the reaction. Action, reaction. Newton's third law. If wedge applies force on the sphere this way, the sphere applies a force on the opposite direction on the wedge. This is Newton's third law. Understood, everyone? Do not show M1G on the wedge. That is completely incorrect. Yeah. Also, another important thing, especially in inclined plane problems, especially where you get confused with the angles, there is a simple trick which you can use. Okay, I'll just tell you what that trick is. Imagine this only is the inclined plane and you want to know which angle is what and all of that. So what you do is show the inclined plane, show the perpendicular to the inclined plane. This is the inclined plane, this is the perpendicular to the inclined plane. Okay, understood everyone? Inclined plane, perpendicular to the inclined plane. Two things. Next thing that you will show is horizontal and vertical. Everybody understood? Horizontal and vertical. How many parts do you see over here? How many regions do you see over here? Put it up in the chat box. Will friction be present, Jinendra? If the surfaces are rough, obviously it will be there. So you might have, maybe if you want to show friction, F1. If there is friction over here, show the reaction of friction here, okay? Because action, reaction. If block applies friction this way, the sphere applies reaction in the opposite way, if it is rough. 8 parts, very good. Why is there no reaction of M1G, hurries? Yeah, so M1G, who is applying hurries? Think about it. Earth is applying. On whom? Sphere. So Newton's third law. The reaction will be on the wedge. No, right? It will be on the earth. Earth pulls the sphere. Sphere pulls the earth. So the reaction of M1G, bacha, the reaction of M1G will be on the earth. Will be on the earth. Understand? So a lot of people, I know, even teachers, when I interview teachers for teacher posts, and I asked, M1G is the force, what is the reaction? They immediately tell me, N1 is the reaction. I am like, how? Newton's third law. Who applied M1G? Earth. Who will the reaction be felt by? Earth. How can N1 be the reaction? It's a completely different kind of force. N1 will be between the sphere and the wedge. They are two different things. Be careful. Yeah. Now, once you make 8 parts, coming back to the trick, guys, horizontal, vertical, inclined, perpendicular. If you know any one angle, let's say for example, you know this angle theta. What is the angle between inclined plane and horizontal? Inclined plane and horizontal? Inclined plane and horizontal, that means this angle is theta. Leave one space, the next angle will be theta. Leave one space, next angle will be theta. Leave one space, next angle will be theta. So easy it is. So easy it is. So once you have 8 parts and you know what is theta, just imagine, guys, if somebody tells you there is one force here, then obviously the two components will be like this, because this angle is between this force and this component, the closer component, close C, cos. So this will be F cos theta. This is far away, you committed a sin, F sin theta, as easy as that. Exactly. Similarly, if somebody tells you there is another force, maybe this way, let's say I call it F2, then you can divide it into two components, one here, one here. This angle is closer to this component, close, cos. So F2, this will be cos theta, this will be F2 sin theta. Understood the trick, guys? You'll never face any problems. Yep. Great. Shall we move to work power energy? Or don't worry, we are going to solve all problems. Lots of questions are coming in. I have doubts on you. I will be able to manage even with this bad throat teaching you guys for next 2-3 hours. Will you be able to sit and are you that motivated? Do you really want 99 percentile? That is something which I want to know from you. Maybe you can tell me in the chat box. Do you have that josh? Do you want to really conquer 99 percentile? Do you really want to really ace 11th standard portion? Do you really want to complete it, know each and every bit, important bit in today's class? That is what I want to know. Work power energy. Let's go. In this chapter, first thing, let's talk about work. In work, main things that you should know is work is force dot displacement. It is a scalar quantity. It is a scalar quantity expressed in joule, 1 joule and 1 erg. These are the two units. 10 to the power 7 ergs is 1 joule. Very good. These are the conversions. And sometimes displacement is not given. So you need to find displacement by final position minus initial position. These are the things. You should also know the sign convention. When is it positive? When is it negative? When is it zero? If it is positive, that means the force and the displacement make an acute angle, or they are in the direction, same direction. Then it is positive work. You are supplying your energy by the force to the system. That is what is positive work. If it is negative, your force and displacement make an obtuse angle or opposite to each other. The body is going this way, you are pulling it this way, you are sucking away energy from it. That is negative work. Zero is when the force is perpendicular to the displacement. Like the moon going around the earth. Or the bob or a ball which is being rotated using a string. The tension or the gravitational pull is perpendicular to the motion. That has no role to play in the work done. 90 degree. Exactly. So that is the main thing about work which you should know. Sometimes there are multiple forces acting. Weight, tension, normal, friction, this, that. Each force will do some work to calculate the total work, find the work done by each one of them and add them, or just find the net force and multiply by the displacement. Either one will work. So that was work for you. Next thing is power. Power is the rate of doing work. It is nothing but how quickly you do work. It is also force dot velocity. The unit is watts. There is also another unit, horsepower. 1 horsepower is 746 watts. This dot product is also very important. It is not force into velocity, it is a dot product. So it is again FV cos theta. Usually many times the angle will be 0 or 180 or 90. So that's why it will be plus FV or minus FV or 0. But if there is some angle, you know what to do. It is force into velocity into cos theta. Okay, so that's a dot product. Now you will get power related problems as well, where you are lifting a bucket of water, or you are climbing up the stairs, or a truck is going on an incline. What is the power? Something like that. We'll be solving questions on that. Just looking at the formula, you might not be still able to solve the questions, because unless you see me solve it, probably you'll not get that confidence. Now, talking about energies, talking about different forms of energies. The different kinds of energies that you know. One is obviously kinetic energy, guys. What is kinetic energy? Kinetic energy is the energy of motion, which is half mv square. You can also write it as momentum square by 2m. Yes or no? Momentum square by 2m. The energy because of the motion expressed in joules. It's a scalar quantity. The another kind of energy that you know is the potential energy. Now this potential energy is because of the configuration, because of the state. It depends on the position. And when you change the state, configuration, the placement, like if I hold the remote here, it has some potential energy because of this configuration, the manner in which it has been placed. If I pull it here, I will see the potential energy has changed because the configuration has changed. If I take a spring, I extend it, I change the configuration, the potential energy changes. The potential energy has different formulas depending on which type of potential energy we talk about. The most important is gravitational in this chapter. There is also spring, and there are other things like electric and stuff like that. Electric potential energy, magnetic potential energy, and so on and so forth. Gravitational potential energy, the formula is when you take a mass, you move it up by height h, the change in the gravitational potential energy is mg into h. The change in the gravitational potential energy. For spring, when you stretch it, the spring potential energy is given by half kx square. These are the two main things which you'll be using in this chapter. Now, the thing about potential energy is that how do you know whether it increases or it decreases? Simple. Everything in this universe wants to reduce its potential energy. Potential energy is like a pain. Do you like pain? No, right? Potential energy, P stands for not potential. P stands for pain energy. Always read potential energy as the energy of pain. Understood? Understood, everyone? Now think and tell me, if I lift this remote up, will its pain increase or decrease? Will its pain increase or decrease? You only think and tell me. You only think and tell me. Obviously, it will become more painful for that guy. It will be like, listen, dear, I want to fall down. You are lifting me up. I want to fall down. You are lifting me up. You are increasing my pain. You are increasing my headache. So the potential energy increases. So what will it try to do? It will try to relieve its pain. Stress buster. Hai na? So it will try to reduce its pain. So always more potential energy is a sad face. More potential energy is a sad face. A system tries to become happy by lowering potential energy. Always the system wants to be that. Okay, so keep this diagram also in your head. It will help you, especially with the signs, whenever you are confused. And when you think that the maths is confusing you, this simple diagram is going to help you. Now, is potential energy related somehow to the force? Because work is related to force and all of that. Answer is yes. In general, if you talk about potential energy, the change in the potential energy is the negative of the work done by the conservative force. Now you might be wondering, what the hell is conservative force? That comes back to work now. So work done by a force depends on the force also. Especially if you want to make the calculations easy, you can use this technique. Coming over here, just look at this. There are two kinds of forces. There are two kinds of forces for finding the work done. One is conservative force. The other one is called non-conservative force. Conservative force and non-conservative force. Examples of conservative force are gravity, spring, elastic, etc. Okay, elastic forces, these are all conservative. Non-conservative is normal, friction, viscous. These are evil forces. They are non-conservative forces. What is the meaning of conservative? Conservative means the work is independent of the path. Independent of the path, and the work done to bring back the object back to its original position by such a force will be zero. The work done will be zero. In a closed path, the work done will be zero. Very, very important thing. Exactly. Here, this is exactly opposite. The work will be depends on the path taken. If you bring it back to the original point, the work done will not be zero. Like if you move an object, friction will suck away some energy. You pull that object back, friction will again do some negative work. Total work will not be zero. It will always suck that energy. So total work is not zero. But gravity is not like that. If you take an object up, gravity will do negative work. If you bring it down, gravity will do positive work. Negative is equal to positive. How much ever it gives, that much ever it takes. So total work done is zero. Clear? Oh? Understood? Oh? Very nice. Now, this formula is very important, especially for potential energy. This formula is very important, especially for when you are talking about potential energy. Okay, so these are important things which I am putting over here, guys. So another important thing is when you have the work done by the conservative force, it is also negative du by dx. This is also very important. Like you might have seen so many questions where energy is given as function of r or x or y or z. You differentiate energy with negative sign, you get the force acting because on that particular body, that conservative force acting on the body. So always potential energy is related to the conservative force or the work done by it using these relationships. Very important. You might have also seen some graphs of potential energy with respect to x, and the graph goes something like this. Potential energy is increasing, potential energy is decreasing as you move the body. If you draw the tangent to the curve, that slope will give you du by dx. The slope will give you du by dx, which is this term. From that you can find the force. Okay? Is this much clear on this particular slide? Now when you solve work per energy problems, what you will most likely need is the term called as mechanical energy or the total energy, which is kinetic energy plus the potential energy. This is the mechanical energy. Now this mechanical energy is constant. When do you think it is constant, guys? When do you think it is constant? If non-conservative forces don't work. If non-conservative forces don't work, then you will see that the mechanical energy is conserved. Example. I throw a ball at an angle. It goes like this and comes down. As it goes up, kinetic energy decreases, potential energy increases. As it comes down, kinetic energy increases, potential energy decreases. Height decreases, potential decreases. Here, the total mechanical energy remains constant. Perfect. Very good example. Another example. I take a spring and a mass. I move this mass, I leave it, it oscillates back and forth. As it goes back and forth, I will see that the kinetic energy goes like this. This will be the kinetic energy, for example. The potential energy will go like this. But there's some which is there, which is the total energy. The total mechanical energy will remain constant, because there is no bad force like friction or viscous which is sucking away energy. As it goes back and forth, kinetic energy increases, decreases, increases, decreases. Potential energy also decreases, increases, decreases, increases. If kinetic energy is increasing, potential is decreasing. If potential is increasing, kinetic is decreasing. But there some will remain constant. These are good examples where energy is conserved. But there are many examples where energy is not conserved. Example, this mass is there and this surface is rough. This surface is rough. What do you think will happen? As this comes down, obviously the mechanical energy will not be constant because of this roughness. It's a non-conservative force. It is doing work. It is sucking away the energy from the block. So it will not be constant. Make sense, everyone? Yep. Ashish, yes, you can watch my lectures. You'll remember. Focus on small targets. Don't try to think about the entire syllabus. Focus on whatever is happening now. Go through the notes that I am giving. Go through the problems that I am giving. Solve those problems. Then do more additional practice. That's what you should do. Great. There is one last thing over here, which is work kinetic energy theorem. Work kinetic energy theorem, which says that the total work done by conservative, non-conservative, internal, external, everything, all the forces will be final kinetic energy minus initial kinetic energy. This can be useful for solving many problems. Also, you will see that many times to find the work, you will find the kinetic energy and then you will find work using this theorem. Sometimes to find work, you find the area under the graph. Like if there is force versus displacement, then if the graph goes like this, then I find the area under the graph. This is positive area, this is negative area. So the total area under which graph? Force versus displacement graph, which is integral f dx, will also give you the work. Okay, so these are different ways of finding work, either via kinetic energy, or sometimes work is given, you find the kinetic energy, or you can use the areas to find the total work done. All these are different ways. Let's move on to circular motion. Now, circular motion, I usually tend to divide it into two parts: kinematics and dynamics. What is kinematics and dynamics difference? 11th physics final yesterday, very good Dilip, welcome to 12th now. And now revise all the 11th portions. Kinematics will only deal with variables like velocity, acceleration, displacement, position, angular terms, right? Whereas dynamics will be all about forces and masses. So in circular kinetics, the most important terms, first one, angular displacement. And you can say this is basically related to how much distance you move on the circular path. If you move a distance of L as an arc, then the length of that arc is radius times the angular displacement. Yes or no? Length of the arc is radius into angular displacement. Next important thing is angular velocity. Angular velocity. Here, the linear velocity is angular velocity into r. Yes or no? If angular speed is omega, then v, which is the tangential velocity, velocity along the tangent, is omega into r. So I'm moving like this. My velocity, my angular velocity is here. My radius is basically this one. This is the circle along which you are moving with some velocity. Omega is called angular velocity. It is also basically rate of change of angular position, d theta by dt. Next important thing, alpha, which is angular acceleration, is rate of change of angular velocity. And this alpha is related to something called as the tangential acceleration. So the tangential acceleration is alpha into r. Notice the similarities. L is r theta, v is r omega, a tangential is r alpha. Very, very similar. Everything is very, very similar. Now, whenever you talk about a curved motion, circular motion, there are always two kinds of accelerations involved. One is the tangential acceleration. This tangential acceleration, will it change the speed or will it change the direction? Will it change the speed or will it change the direction? Think about it. This is the radius, this is the center. It is going with certain velocity over here. What do you think? Does the tangential acceleration change? No, it does not change the direction. It changes the speed. What does it change? It changes the speed of the particle. Always it is in the direction of the velocity. It changes the speed, the length of the velocity vector. Keep this in mind. But if you look at the centripetal acceleration, which is given by v square by r or omega square r, this changes direction. It is responsible for changing the direction of motion. Keep this in mind. Understood? So all these are important things in kinetics. Then you have another important thing called as uniform circular motion. What is so special about uniform circular motion? Many people ask. The speciality is angular velocity is constant. Angular acceleration is zero. There is no acceleration. The angular velocity is constant. In fact, that also means the magnitude of the velocity is constant. It also means the total acceleration is only centripetal, because the tangential acceleration is not going to be there. There will be no tangential acceleration, no changes in speed. It will go with constant speed. Constant speed, that means the only thing which is changing is the direction. So only centripetal acceleration is there. Understood, guys? Everyone? Awesome. Another thing is the time period. The time period of such a motion is 1 by frequency, or frequency is 1 by time period. Also, angular speed is 2 pi radians by the time period. These are two special formulas which you can use only for uniform circular motion, not otherwise. Yes, Ananya, that will be a overkill if you do Ekalavya module questions. It is mainly for advanced, not for mains. Unless you are doing the mains level question, I think it will be overkill than what is required. Another important thing. Okay, coming back. In circular kinetics, you might have uniform circular motion. Obviously, the other thing that you can have is non-uniform circular motion. So in non-uniform motion, circular motion, if alpha is not 0 but alpha is constant, then you can use kinematic equations. Remember, just like in linear motion, if acceleration was constant, if acceleration is not changing, then what do you say? V is u plus at, s is ut plus half at square, and so on and so forth. Same thing you can say, but the variables will change. Instead of velocity, it will be angular velocity. So final velocity will be initial velocity plus acceleration into time. Displacement will be velocity into time plus half acceleration times square. Then final velocity square will be initial velocity square plus 2 times acceleration into displacement. These are the equations which you can use if acceleration is constant in circular motion. Yes, it's just directly related. So that's what are the important things in circular motion. And in kinematics or kinetics, the second aspect is dynamics. Now in dynamics, remember, first thing is the centripetal force concept. Centripetal and tangential forces. So if you have a particle going in a curved path like this with some velocity, understand it might be changing its speed. If it is changing its speed, it has tangential acceleration. If there is acceleration, there must be a force. So that force causing the tangential acceleration is the tangential force. It changes the speed. What does it do? It changes the speed. If it is going in a curved path, the direction is also changing. So it should also have centripetal acceleration. So that also means there must be a force causing the centripetal acceleration. So there will be Fc also. This will change only the direction. The total force will be the resultant of these two. So F bar will be Fc bar plus Ft bar. This will be the net force. Now, a lot of people think, sir, isn't centripetal force a new kind of force? The answer is no. I'll tell you why. Imagine if you have a mass and it is going in a curved path like this. Okay, just imagine. And I tell you some forces, okay. Example, there is a spring force, Kx over here. Let's say there is a mg over here. And let's say there is normal over here. Example, okay, just randomly I have drawn. Now, if you see where is it accelerating, the first acceleration I will show is towards the center. So centripetal, it might also have some tangential acceleration. Yes or no? Everybody with me? Okay. Let me also mark the angles. Let's say this is theta 1. Let's say this is theta 2. Now think, in the direction of acceleration, centripetal, which forces are there? In the direction of centripetal. In the direction of centripetal, which forces are there? I think kx component is there. So let me write down kx. Which component is there? Cos theta. So kx cos theta 1. mg's component is also there. So plus mg cos theta 2. Normal is there, but it is opposite. So minus n. This becomes your total force in this direction. Kx component, mg component, normal, opposite. This will be mass into centripetal acceleration, which is mv square by r or m omega square into r. Whatever you want to say. Hold on, Karthik. We'll talk about centrifugal later on. First look at this. Hello, Gopika. Centripetal force. Which one is centripetal force? Guys, have I shown centripetal force here? That is a common mistake which students do. Many students show, sir, centripetal force, mv square by r. If some teacher has told you to draw this, they have lied to you, they have fooled you, they have not taught you properly. If you show this, that's the biggest mistake you can do in physics. It's not a force. No, don't show this. It's stupidity. Okay? This is not a force. In fact, this is the centripetal force. This whole thing is called as the centripetal force. So it's not a new kind of force. Understood, guys? Next important thing. If you look at the tangential direction, along the tangent, component of spring is there. How much component? Sine theta. So sine theta. Also, mg's component is opposite. So minus mg sine theta 2. This force minus this force. Kx component, mg's component is opposite. Is going to give you mass into acceleration. Normal will have no component because it is perpendicular. Is mass into tangential acceleration. You can write it as alpha into r. Also, it's up to you. This whole thing is the tangential force. So realize this. This whole thing here was centripetal. This whole thing here is tangential. Now, is it very clear in your head? Evening we will not have classes, Gopika. Yep. No, we are going to have many questions, Ananya. Is that clear? Okay. Now what about centrifugal force? Centrifugal force is just a pseudo force, guys. So centrifugal force, it's just a pseudo force. That's all. And the value of this centrifugal force is nothing but m omega square r, and it is always outward. When do you apply it? You apply it only when you are rotating. When you are rotating frame, only then you apply the centrifugal force. Otherwise, you do not apply. Example, I am in a merry-go-round. Imagine this. I'm in a merry-go-round. Look at this Pandu. If this Pandu is on that merry-go-round, and if he sees any object over here, is he not in a rotating frame? What will he feel? He'll feel that somebody is throwing that box out. He's on a merry-go-round. He'll feel that the box wants to fly out. That pseudo force will be outwards. Value is m omega square r. R is this distance. Omega is the angular speed. M is the mass of the block. Is that clear, bachalo? So that is basically a pseudo force, because when you are rotating, you get the tendency you are being thrown out. That false notion tells you you are a non-inertial frame. It's not inertial, it's a non-inertial frame. That's basically the concept of pseudo force in circular motion. Well, after a long time seeing Pandu. Thank you so much, Gopika. Sir, will I start any revision or classes for NEET? If you do so, it will be useful. Definitely, Sana. Aim is there. I want to take 2 classes, but my throat, if I take 2 classes, I will not be able to take the next day. So that's the reason why I'm putting all my energy in this one class, but which is a big class. Even NEET students can watch it. Okay. Let's go ahead. One last thing before we start with the problems. I know you guys are all waiting for the problems. If you have a string, and you want to throw a mass such that it completes the vertical circular motion. It completes the vertical circular motion. So for the complete loop, the minimum velocity is root of 5 GR. Root of 5 GR. R is the radius or the length of the string. If instead it was not a string but a rod, if it was a rod and you have this mass and you have to give it certain velocity so that it completes the circular motion, for the complete loop, the answer is root 4 GR. That is very important. Last thing over here, if you don't want it to go completely, but only till this point, only from here to here, then the velocity for half that particular loop, only half of it, it will come like this, go here, come like this, go here, like this. So that will be just root 2 GR. Whether it is rod or string, it does not matter. So here also for half of it, it is still root 2 GR. The only change comes here when you want to make it go completely. So that's how it is. Remember, when it goes in a loop, here the speed is root 5 GR. By the time it reaches here, the tension is least and the speed is just going to be root GR. As it is going here, root 5 GR, root 4 GR, root 3 GR, root 2 GR, root GR. Again, root 2 GR, root 3, root 4, root 5. So that's how it goes. Here, in case of rod, even if the speed is 0, it does not matter. The speed is basically very close to 0. 0.01 meters per second. It slows down, just stops and it goes out like this. It stops almost and goes down. So a rod can, bear compression. A rod will not succumb when there is force acting on it, whereas a thread will slack. You cannot push a thread. You can pull a thread, it will become tight, but if you leave it, it will become slack. So that's why you need more speed in a string, because a string needs that tension. Rod, it's okay, it will hold it. It can hold. String cannot hold. Is that okay, bacha? Can we do some questions? Okay, start. Have you smashed the like button? Ready for questions? Just type ready for questions. Yes, Jitendra, because centripetal acceleration is inwards. That's the reason why on that non-inertial frame, you do not show the centripetal acceleration. Instead, you show the pseudo force which is outwards. It's just like in your normal things. If you are on the ground frame, acceleration is shown this way. If you are in that moving frame, then you show the pseudo force the other way and you forget the acceleration. That's exactly what it is. Great. Chalo, start solving this. I'm just going to get one small cough tablet. Just give me 1 minute. I'll be back. Meanwhile, start solving. I'm waiting to see all your answers. Okay, I'm just going to be back. Just give me 1 minute. Okay, some of you have started posting answers. Let's have a look. Two blocks, masses 3 kg and 1 kg are in contact and all of that. Okay, this is 1 kg, this is 3 kg. The force of 20 Newton is applied on the larger block. 20 Newton is applied on the larger block. So what is the force between the two blocks and what is the acceleration? So if you take 1 plus 3 kg as a system, the only force is 20 Newton. As a whole, it will have some acceleration. So using Newton's law, 20 is equal to 4 into A. So acceleration is 5 meters per second square. Correct? Now 5 is there only in B and C option. So A and D gets ruled out. Now in order to find the force between them, show the free body diagram of any one of them. Let's say I show the free body diagram of 1 kg. There will be a force from here. Let's say I call it R. 1 kg block will also have the same acceleration of 3 or the system as a whole. That's it. That's the only force in the horizontal direction. So R will be equal to mass into acceleration. Acceleration is 5. So R will be also 5 Newton. So 5 Newton and 5. So that means option B should be correct. Yes, it is. Now you tell me in the chat box, if I change one small word here, the force is applied not on the larger block but on the smaller block. I just changed this word. That's all. Rest question as it is. Do you think you will still get the same answer? Yes or no? If I replace this word larger by the word smaller, oh my god, yeah, then do you think the final answers for acceleration and the internal force, will it remain same or no? No. I think yes and no both. Why? I'll tell you. The acceleration will be the same. This answer will not change. Yes, very good, Jinendra. Yeah, this answer will be the same. Yep. But this answer, that will change. In fact, it will become 15 Newton. Okay? Why? Because whether you push it from here or here, the total mass will accelerate by the same amount. But if you want to find the force on between them, then I would prefer showing FBD of 3 kilo. Then 3 kilo will have 3 into A, 3 into 5 is 50. That's how it is. Exactly. Very good. So that's all things that you should be careful about. These kind of questions can be asked and they have been asked many times. Next question. A rocket of certain mass, very common question, ejects a mass with constant relative speed. What is the acceleration after 5 seconds? So this is our rocket. It is ejecting out some mass. So whatever is the mass which is left will be initial mass minus the burnt mass. The initial mass was 6000 kg minus how much mass is burnt in 5 seconds. Every second 200 kg. Every second 200 kg. Like that 5 seconds. So 200 into 5, which is 1000. 6000 minus 1000 is going to be 5000 kg. Yes or no, guys? 5000 kg. Now, once you find the mass left, the next part starts. Show the forces or think about the forces. Basically, the thrust force of that rocket is basically applied on the gases. The reaction is on the rocket. So the reaction is on the rocket that causes acceleration. So I can just say that the thrust force by the exhaust gases pushes the rocket up, and that will be mass into acceleration of the rocket. The value of the thrust force you should know. It is velocity of the gases or velocity relative to the system of the particles being thrown out into the rate of change of mass, that is dm by dt. So this will be equal to m into A. V is known, I think, 800. Rate of change of mass is 200. The mass which is left is 5000. 5000 into A. 0, 0, 0, 0, 0, 0. 80 into 2, 160 divided by 5, guys. Yep. So what is the acceleration going to be? 332 meters per second square. That's it. Where is it? Option D. Now, What is important is that this thrust force, usually you will see this thrust force formula not given in many books, but I am telling this to you. Where does this come from also? This comes from rate of change of momentum. So when you do rate of change of momentum, that's how you get the value of the thrust force. That's all. Okay, everyone with me? Understood? So the main thing that you are taking away from this particular question is the value of thrust force is velocity relative to the system with which the particles are ejected out into the rate of the change of mass of the system. That is the value of the thrust force on the gases or on the or which the gases put on the rocket or on the system. Next question. 10 coins. 10 coins. That's why you are going to learn from problems, not just definitions. 10 coins, 10 gram each, one above each other. Reaction by the 7th coin on the 8th coin. Let's have a look at this. This is our ground. This is the first coin. There are many coins over this. Let's say this is the 7th coin. This is the 8th coin. This is the 9th coin. And this is the final 10th coin. This is how it is. Question is, what is the reaction exerted by the 7th on the 8th? So, you know what I feel? We should probably consider only the top 3 coins. 7 on 8. On 8. That means external force on 8. So make 8 as a system, but not just 8. Put 9 and 10 because 9 will also apply some force. So how about taking 8, 9 and 10 coins as our system, and the 7th coin will exert a reaction. I will call it as R. Is that understood, guys? Now, if you look at this particular system of only 3 coins, these 3 coins have their own weight. What is their weight? Mass into G. What is the mass? 10 gram. That means 10 into 10 to the power minus 3 into G, but there are 3 such coins. That's why into 3. Do you understand why 3 is there? Because 1, 2, 3. 3 coins, each coin mg, mg, mg. So that's why into 3. Now, that's it. The reaction force will be also equal to the weight, because there are only 2 forces. Reaction from the bottom, weight of the 3 blocks together. That's it. So this will be nothing but 3 into 10 to the power minus 1, which is 0.3 Newton. Is that option there somewhere? 0.3 Newton, option A? Yes, it is. There you go. Very good, Isaac. Newton, just again. Yeah, tech crunch. Yep. Is that clear, bacha log? Very nice. Very nice. If the question was, find the reaction on the 7th because of the 8th, then what will you do? If the question was, find the reaction on 7th because of 8th, then what will you do, guys? Let's see if you guys are smart enough for this trick question. But they aren't in the opposite direction. Does that have anything to do with the problem? Who is this? Jinendra, this weight is acting on the block. The reaction is also on the blocks. So these 2 forces should cancel out each other because they are in equilibrium. So net force is 0. Therefore, the reaction from bottom to the top should be equal to the weight which is acting downwards. That's why weight is equated to R. The answer will still be 0.3 only, just that it will now be downwards. That's all. So we'll just say it is 0.3 downwards, obviously by Newton's third law. If 7 applies a 0.3 Newton on 8, then 8 also applies 0.3 Newton on 7, but in the opposite direction. That's all. I hope that is clear. Moving on to the next question. A balloon of certain mass is floating on the Earth's surface. 200 kg is thrown out. The balloon starts to go up. What's the acceleration of it? Okay. So this is a balloon. It is at rest. How can it be at rest? Think about it. There is only one way. If the weight which is there of the balloon, which is 1000 G, is somehow balanced by which force? Obviously buoyant force. So because it is at rest, net force should be 0. So buoyant force should be equal to the weight, which is 1000 G, which is 10 to the power 4. That's the buoyant force. Is that making sense, everyone? Great. Now, the next part. You throw 200 kg out of the balloon. That same balloon, the mass will reduce. Instead of 1000 kg, it will now become 800 kg. But the buoyant force is still going to be 10 to the power 4 Newton. But what will reduce is the weight, which will now become 800 G. Because of that, there is an unbalance. That's why it will begin to accelerate up. So now you can say that 10 to the power 4 larger force minus 800 G will be mass, which is 800 into acceleration. You can remove 2 zeros here, so this will become 10 to the power 2 minus 8G will be 8A. This will become 100 minus 80. 8G is 80, so that will become 20 is basically equal to 8A. So A will be nothing but, just check this out, 20 by 8, which is also basically, if I divide by 4, this will be 5 divided by 2, which is roughly 2.5 meters per second square. 2.5 here, it is 2.45. Now I feel that they have taken the value of G as 9.8. That's why they have got it as 2.45. If I take the value of G as 10, then I'll get it as 2.5. But will I again cancel this out and solve the problem? No. Why? Because I know the answers are close by. So 2.45, 2.5 close by, so I'll just mark option A. Is that okay, bacha? Silent killer, please somebody answer silent killer. Yeah. Is that understood, bacha? Very good. Very good. Great. So the concept here is understanding that the buoyant force is there. Second concept is understanding that when you remove the mass, then there is an unbalance because of which it accelerates up. So just write Newton's law, net force is mass into acceleration, and solve. Even if the answer is not exactly matching, I know that is only because G value is 9.8 or 10. That's all. Moving on to the next question. In this question, if a force is applied on the mass M2, then if everything is ideal, table is smooth, find the acceleration of mass 2. Find the acceleration of mass 2. Shaku, buoyant force came because there is no other force which can balance it. Can friction be there? No. Normal? No. Spring? No. Somebody is pulling it by a thread? No. Pseudo force? No. Buoyancy is only in water. Who said that? Buoyancy is any fluid. Fluid means any air or liquid. Even air exerts buoyant force. Just that the buoyant force of air is very small for most of the objects. But when you have a big hot air balloon, the volume is so large that the buoyant force becomes significant. Okay? Thank you, silent killer. Constant force is acting. Question is, what is the acceleration? Simple, guys. Over here, if you write down what is the tension, the same tension will go over here. This mass will have its own weight m1g. This will accelerate up or down. I think this force is less. So I think this will accelerate downwards. How do I know it is accelerating downwards? Is because this force is just m1g by 2. This is m1g by 2. This is m1g. More force there, less force here. So this is going to go this way. This is going to go this way. That's it. Now, one way is you write equation for this, and you solve them, or use a mind-blowing method. Open this entire system up. Open this entire system up. Something like this. Open this entire system up. So this is your M2. This is your M1. So if you open this up, this force will still be M1G by 2. Tension is there. It is internal. When you make this go up, the force will also tilt. It will now become M1G over here. This will accelerate here. This will accelerate here. Treat this as your system. Opening up method, this is called. Opening up method. Treat it as your system. Now this tension will now become what? Internal force, yes or no? Internal forces. Which are internal forces? This tension and this tension will become internal force. Forget everything else. Only look at the external forces. This is one force, this is one force. It is accelerating that way. So I can just say net force is mass into acceleration. Net force is m1g minus m1g by 2. Total mass is m1 plus m2. m1 plus m2. Whole thing into a. This will become m1g by 2 is m1 plus m2 whole thing into a. Naturally, what will be the value of a equal to b? m1g whole thing divided by 2 divided by m1 plus m2. That is it. Option A. Definitely, guys, you are going to see me very soon. And if you guys are in Bangalore and you want to meet me, do let me know, guys. We'll set up a meet. Or if you are coming down to Bangalore for some reason, let me know. We can plan a small meetup. We can have fun. We will also probably learn new things. We can meet in the office also. Yes, in the Vedantu office we can meet. Definitely, it will be amazing. Many students do come down, but that is at random. Like, they don't give us warning. Suddenly they come and they're like, hello sir. But many times they don't meet any teachers because not every teacher goes to the office every day. So if you tell me that, sir, we are planning, then we can plan a nice meet, probably after your boards or before your mains or even after your mains, up to you how you want to do it. Next question. VV Puram you came to. Oh my god. A little bit far from my place, but yeah. But yes, it doesn't matter where in Bangalore we can meet. Two bodies of masses 15m, 25m connected by string. 40, 10 centimeters, mass 10m. The string is made to pass over a pulley. Bodies are at same level, released by the time the heavier mass goes down. What is the acceleration going to increase or decrease by? I'll definitely come to Tamil Nadu also, bacha, soon. Why not? If you guys plan a meet, I'll definitely come. Why not? I've been to Chennai, Salem, Madurai, also Pondi, so many times. I like the food, I like the people over there. It's amazing to see meet my friends also. Trichy I have not been to, bacha. Maybe someday. Okay. So over here, what you need to do, bacha log, is that initially this mass is heavier, this mass is less. This rope also has some mass. That's the catch. That's the catch. Okay, be careful. There is some acceleration, but as it goes down, as the rope has mass, the masses on both sides will change, so the acceleration will be different. I'll tell you why. Hold on. See, this is 15m and 25m, right? So there is 25 mg. There is also 15 mg over here. But the rope also has a mass of 10m. That means 5m mass is here, 5m mass is here. 5m mass is here, 5m mass is here. So actually extra 5 mg is here and extra 5 mg is over here. Did you understand? The rope also has some mass, so that also needs to be considered. Now this side is heavy, this side is light, so obviously it will accelerate towards the heavier side. Heavier side will go down, lighter side will go up. So if you want to find the initial acceleration, A1 if I call it, will be bigger weight minus smaller weight upon total mass. So bigger weight 25 plus 5 mg minus smaller weight 15 plus 5 mg, correct? Whole thing divided by total mass, which is 25 plus 15 plus 5 plus 5 m. See what will it come out to be? Everyone just see what will it come out to be. Come on bacha log. What will it come out to be? Think about it. 25 plus 5, 30. 15 plus 5, 20. 30 minus 20, 10. So 10 mg. Whole thing divided by 25 plus 15, that is going to be 40. Plus 10, that is going to be 50. So 50 m. that is going to make it G, 0, 0 cancels, mm cancels, G by 5. Yes or no? That's the old acceleration. Mm will also cancel. I think you forgot that m. Now keep this aside. Now think what will happen after this mass basically comes down. Just imagine this is no longer here. Okay, this is no longer here. This is also no longer here. Okay, this is also no longer here. Just make this go up and make this come down. So imagine this went here and this went down. Now the distributions will change. That's the main thing, guys. This 15 mg and 25 mg will still be the same. This 15 mg and 25 mg will be the same, but because 10 more centimeters has gone there, 10 more centimeters has gone there, what will happen? The total length will become over here 30 centimeters and over here it will become 10 centimeters. Yes or no? 30 centimeters and 10 centimeters because total length is 40 centimeters. Unequal shift. Now think, guys, 10m is the mass for 40 centimeters. 10m is the mass for 40 centimeters. So for 10 centimeters, how much is the mass? 10 by 4m, which is basically 2.5 m is the mass for every 10 centimeters. 2.5 m is the mass for every 10 centimeters of the string. Okay, guys, I don't think there will be a break for this particular session. Okay, so you'll have to manage. Now, if you only take this much part, what will be the weight of that string? That will be only 2.5 mg. Yes or no? 2.5 mg because it has 10 centimeters. So for 30 centimeters, how much will be the weight? Think about it. For 30 centimeters, how much will be the weight? 2.5 into 3, which is basically 7.5 m. Yes or no? 7.5 m. So this part of the string will apply additional weight of how much? 7.5 mg. Got it? Now you can see the weights on both sides have changed. So there will be a new acceleration which will be bigger weight, which is 7.5 plus 25 mg minus smaller weight, which is 15 plus 2.5 mg. Total weight will still remain the same only, guys. Total weight was 50 m. It will still remain the same. It will not change. It will still remain as 50 m only. Okay. This will become nothing but 32.5 minus 17.5 mg upon 50 m. mm cancels. This will just become 15 by 50 g. 5 goes with 15 goes with 5 3 times. This goes with 5 10 times. That's the old and the new accelerations. Now just divide A2 by A1. A2 is basically 3g by 10. A1 is g by 5. A1 is g by 5. G cancels, 5 goes with 10 2 times. So this will be 3 by 2, which is 1.5. So A2 is 1.5 times of A1. That is the answer. That is the answer. Where is it? Increases by a factor of 1.5. Exactly. Gopika, on Instagram I have not posted, but on Telegram I have posted. I have also posted on the community. So if you have checked out the YouTube community and the Telegram, I have pinned the message and kept it. So every day 10:30. But do you have biology class? Biology exam also? Or have you taken up biology? Because in that case, maybe I think you have your exam on 15th or 16th. So if you want me to change the timing to evening time only for that day, please let me know in the comment section. Yeah, but it's a good question, guys. It's a very good question. Don't expect that this question can't come. It can come. Yeah. Last class notes are also there, bacha. I don't know whether you have seen it in the Telegram channel. There is a link which I have pasted on another channel. So make sure you go to that channel and make sure that you join that channel, and from that you will get the short notes. There's a link in the Telegram channel. No thanga, otherwise only on 16th I'll take on evening if you want me to, but otherwise I'll take in the morning, no issues. But you put it up in the comments after the session is over. Where does this formula come from? That is the shortcut trick. Basically, remember when I was giving you the notes of Newton's laws, I told you over there, it basically comes from the fact that, imagine if you have a system, you have larger force here, here you have smaller force, and this is the total mass of the system. Where will the system move? Towards the larger force. That is where the acceleration will be. So can't I say larger force minus the smaller force is equal to mass of the system into acceleration? So won't acceleration be large minus small divided by the mass? That's all. That's how it comes, Jinendra. Okay? Simple. Newton's law. Net force is mass into acceleration. That's all I have done. Got it? Okay. Moving on to the next question. A pendulum of mass m hangs from a support fixed to a trolley. The direction of the string when the trolley goes up the plane of inclination 30 degrees with acceleration of 10 is how much? Interesting question. Very interesting question. Many students will do crazy things to solve this. But I will show it to you in a very simple way. This is a pendulum. The question is, what angle does it make as it accelerates up the inclined plane of 30 degrees? That's what the question says. Now what I'm going to do is just look at that mass and show its free body diagram. But before showing free body diagram, let me also draw our standard lines divided by 8 parts and now show the free body diagram. The first force that I'm going to show is the weight itself. So that is mg, which is basically 10m. G is 10, so 10m. That's the thing. Another force, because it is accelerating up, will be the pseudo force. So the pseudo force will act this way. So this will be the pseudo force, which will be mass into acceleration, which is again 10m, because acceleration is also given to be 10. Interesting thing. Weight is also 10, pseudo force is also 10. What will happen, guys? The resultant, won't it bisect both these things, and won't it come exactly in between them? Won't it come exactly in between them? So this is the net of Fp and the weight. Yes or no, guys? Very good. Now think logically. It is clearly mentioned. Oops, where did it go? What just happened? Oh my god. All this, whatever I did. Oh my god. Okay, looks like it went somewhere. I don't know what happened. Okay, I'll just draw it, guys. Just cooperate now. Okay, 8 parts. Okay, now my dear students, look at this. The angle of inclination is 30. Angle of inclination is 30. So won't this angle be 30 degrees? Yes or no? Won't this angle be 30 degrees? Yes or no? Perfect. If that is 30, won't this also be 30 degrees? Won't this total angle be 60 degrees? If that total is 60, won't this force divide this into equal parts? So each of them will be 30 degrees and 30 degrees each. Yes or no? Everybody fine till this point? Okay. This is 30, opposite is 30. So 90 minus 30 is 60. 60 will be divided equally because this force and this force are equal. So the resultant will be exactly equidistant or bisect the angle between the two forces. Perfect. Now, what about tension? You are wondering. What will tension do? It will try to balance the net force. Weight and pseudo's net force will be balanced by the tension. So tension will be exactly opposite to this blue line, if you want to say so. It will be exactly opposite to this blue line. That's where the tension will be. Yes or no? Acha. Now this is 60. Now this is 60. Think about it. So won't this angle will also be 60 degrees? Won't this angle be 30 degrees? Think about it. Oops, sorry, I think that is not 60, my bad. That is 30 degrees only. This is 30, this is 30. Yeah, this is between these two lines, so that is also 30 degrees. Yeah, this is 30 degrees. Check this out. All these angles are 30, 30, and this is also 30, 30 plus 30 plus 30 is 90. This is very important for solving the problem further. Very, very important. Trust me, why I'll tell you. Now, if you look at this box, that's it. See, your physics part has ended here. Now it's only geometry. If you notice, it's angle, angle, angle. That's all. Physics part has ended. If you look at this box, and that pendulum, guys, okay. Now observe carefully. The vertical line is this one. The perpendicular to the incline is this one. This angle, how much will it be? Think about it. This angle, how much will it be? If this is 30, how much will this angle be? Think about it. This is the perpendicular to the incline. Perpendicular to the incline. This is incline. This is your vertical. How much will that angle be? Is it 60 or 30? Think again carefully. I don't think so. Guys, this is not 60. 60 is this whole thing. This will be only 30 degrees. This will be only 30 degrees. Check this out. Only this angle will be 30. This total angle is 60. So total being 90, 60 plus 30 is 90. So this is only 30 degrees, yes or no? This is only 30 degrees. Very good. Thanga, the question says, find the angle which the pendulum makes with that perpendicular. So now I think it should be obvious for all of you what is happening over here. What is happening over here? Guys, with the vertical, tension makes 30. With the vertical, tension makes 30. With the vertical, tension makes 30. If this is 30, how much will this be? This is also vertical, this is also vertical. With the vertical, tension makes 30. So won't this also be 30 degrees? Won't this also be 30 degrees? That's it, guys. Now what is the angle which the pendulum makes with the perpendicular of that box with this dotted line? This total angle will be 60 degrees. Hence, that's the answer. Option C. That's all. Option C. It's completely a geometrical question after this free body diagram. Nothing else. So I'll repeat. In this question, the question was to find out how much angle does this pendulum make. Because when you accelerate the box, the pendulum swings behind. So it will make a new angle. How much angle it is? So for that, I found the resultant of the weight and the pseudo. That resultant will be balanced by the tension. I started marking all the angles one by one. From that, I understood that the internal angles are 30, 30, and the total angle is 60. Clear? So you'll have to replay this question. You cannot by heart this number one. Try it out on your own. You will get stuck. Again, try out from that point. You will again get stuck. Try out from that point. See what I have done. You might find your own way. That's okay. But this question can come in JEE Mains, and very few people will be able to do it. Moving on to the next question. Coming up on your screen. What is this? A stationary shell explodes into two fragments. Mass ratio 1:2. Heavier fragment moves with a kinetic energy 100. Then what is the total energy released from that particular explosion? That's the question. So first of all, if you have a total mass of 3m, why 3m? Because the ratio is 1:2. 1 plus 2 is 3. So I divided it into 3 parts. One part m, the other 2 parts 2m. This goes this way, this goes that way. What will be same for both of them? Velocity? Velocity? No, right? It will be momentum. Why? Because momentum has to be conserved. Momentum is conserved. If it is conserved, think about it. Initial momentum was 0. So final should also be 0. That means if this guy has a momentum of P, this guy also has a momentum of P, so that they cancel each other. Yes or no? Perfect. Now think this way. Kinetic energy is momentum square by 2 times of mass. That's the formula. Now momentum is same for both. 2 is a constant. So can't you see kinetic energy is inversely proportional to mass? Kinetic energy is inversely proportional to mass. So K2 by K1 will be M1 by M2. M1 is M, M2 is 2M. So it will be 1 by 2. That is K2 by K1. I hope this is clear. I hope this is clear. So M1 was M, M2 is basically 2M, so that's K2 by K1. Now K1 is given to me as 100, just check this out, everything is fine. Yeah. Just check this out, everything. Okay, so the kinetic energy of the heavier fragment is 100, which is the heavier one, which is K2. So K2 is 100. 100, yes. K1, I don't know, is equal to 1 by 2. So K1 will become 200 joules. Just check this out. Now 200 joules is there in the answer, but do not mark that. Do not mark that, because the total energy released in the explosion is asked. So the total energy will be K1 plus K2. So K1 is 200. K2 is nothing but 100. So the total energy of that explosion will be 300 joules, which is option C. Yep, that's the answer. So it is clearly mentioned of the heavier fragment. Which is heavier? 2M, M2. That means K2 is basically 100. K1 was unknown. A lot of students make a mistake while substitution. Second mistake, they find out 200 and mark 200. They forget reading the question. You have to answer what is asked, not what you get. You might get something, but that is not what is asked. What's the point? Moving on, next question coming up on your screen. Why K2 by K1, sir? You can take K1 by K2 also. If you take K1 by K2, it will be M2 by M1. Krishna, doesn't matter. Whatever you do, you'll get the same answer, right? Yeah. Gopika, I feel you should attempt physics first. If you think you will not get scared by it, but if you feel like, no, I want to secure marks, then do biology first, finish it early, and then go to physics. If you get scared or you might lose confidence, then you should do biology. Else, I would say do physics first. A 10 kg stone is suspended. Breaking strength given. The minimum time in which the stone can be taken up by a height of 10 meters. How much will it be? So imagine this is your 10 kg stone. There is this thread. There is its own weight, which is 10 G. Tension is also there, because of which it is going to accelerate. If you want to take it as quick as possible, what will you do? This tension will be as large as possible. The max tension is 30 G. Beyond this, it is going to break. So if I apply Newton's law, which is net force is mass into acceleration, 30 G minus 10 G will be mass, which is 10 into A. 0, 0, 0 cancels. So 3G minus 1G, which is 2G, is equal to A, or A will be basically equal to 20 meters per second square. Everybody with me? Everybody with me? Now what will you do, guys? Once you get acceleration is 20 meters per second square, read the question. If you want to take it from one point to the other point by a height of 10 meters in minimum time, in what is that minimum time is the question. You start over 0 at t is equal to 0 from rest and you accelerate up. So question is, what will that time be? I think you know displacement. You need to find time. Use kinematic equation. S is ut plus half at square. S is 10, u is 0, acceleration is 20, time is not known. This will become 10, 10 and 10 also cancels, 1 is t square, t will be 1 second. How many of you got it? Option B it is. Got it, guys? Perfecto. Can we move ahead to the next question coming up on your screen? Get ready for it. A man inside a lift. Lift is moving up with acceleration. The change in weight is 25%. And the lift goes down with double the acceleration. The new change in weight is how much? Let's go to this question. Let's see if you guys can solve this before me. So first case, the lift is going up with certain acceleration. So obviously the apparent weight will be mg plus ma. And it is given that it is 25% more. It is change in weight is 25%, and it will be more because it is going up. So the apparent weight is 25% more than mg. That means 1/4 of mg is extra. Which is that extra part? ma part. ma is that extra part to mg, which gives rise to that extra weight or changes the apparent weight. So can I not say mg by 4 is ma? Therefore a is equal to g by 4. That's the first condition. Now in the second condition, the lift goes down. Second part, double acceleration. If you miss these words, you might get a wrong answer. The acceleration now is 2 times g by 4. That means it is g by 2. Now the new apparent weight will be mg minus m into a. So this will become mg by 2. So this is mg minus mg by 2. That means it is 50% less. So the apparent weight is 50% changed. It's not 25%. Many students forget to read this word double. The moment you forget to read this word, you will get the answer as A. So that's a common silly mistake. That's why you should read the question carefully. You should never be in a hurry. Mark important things or write it down. You cannot mark it because it's a computer-based test. Write down the important things so that you do not make a mistake. Read again and again. Don't miss any terms. If a frame of reference moves with constant velocity or acceleration, it is non-inertial. If it moves with constant velocity, it is inertial, Naveen. If it moves with acceleration, whether it is constant or not, it is non-inertial. Okay, Naveen? Constant velocity means zero acceleration. Forget velocity. Always look at acceleration. If acceleration is zero, inertial. Acceleration is not zero, non-inertial. Simple. Okay? So let's solve this question. Two blocks 7 kg and 3 kg are connected by a spring of stiffness so and so. They are acted upon by forces this and this. What is the acceleration of the block when it is moving with constant acceleration? And the extension, sorry, when the accelerations are equal, then what is the extension of the spring? Now it is given that the acceleration of the blocks are equal and constant. Very important word. So this is 32, this is 72. So net force will be that side. So if this block accelerates this way, this block will also accelerate this way by the same amount. Okay, everybody fine till this point? Now let me do one thing. Let me take the complete thing as a system. So M1 plus M2 plus spring as a system. The moment I do that, spring force will become internal force, yes or no? Spring will become internal force. It will become internal force. The only external forces are 32 and 72. 72 is big, 32 is small. So can I say big force minus small force is total mass 7 plus 3 into acceleration. What is this? This is net force is equal to mass into acceleration. That's all. So 72 minus 32, 40. 7 plus 3, 10 into A. So how much is A? It is 4. But that's not what is asked. Question is, what is the extension? How do I do that? You take the free body diagram of any one of them. Take any one of them. Doesn't matter. Let's say I take 7 kg or you take 3 kg. Doesn't matter, guys. So let's say, for example, you take 3 kg mass. What are the forces acting on the 3 kg mass? One is 72 Newton. Other is kx. And it is accelerating with 4. That's it, right? Nothing else is there. Now from this FBD you can find x. How? Observe. 72 minus kx is equal to mass into acceleration. Mass is 3, acceleration is 4, 72 minus k. What is the value of k? 1000. So 1000x. So basically 1000x will be 72 minus 3 4s are 12, which is basically 60. So basically 100x is basically 6. X is 6 by 100 meters. 6 by 100 meters means 6 centimeter. Yes, that's the answer. Sir, here acceleration is constant. Yes, it is given. It is given that it is constant. Read the question. It is moving with constant acceleration. Stiffness means spring constant. Yes, Naveen. Stiffness is, you can see the unit, 1000 Newton per meter. I think that one has come over here. It is per meter. Newton per meter is spring constant. As simple as that. Got it? Moving on. Next question. There is a rope with certain mass or rod with certain mass. Total mass is given. Total length is given. Two forces are also given. Find the force in between somewhere. 15 from here, 45 from there. Common question. A rope or a rod with mass. What is the tension at any given point? How to solve this? First of all, take the entire rod as a system. If you take the entire rod as a system, the forces acting on it are 45 Newton. Then you have 21 Newton, because of which it will accelerate. First find acceleration, then find everything else. How will you find? Bigger force minus smaller force is mass of the rod into acceleration. So this is just net force is equal to mass into acceleration. 45 minus 21 is 24, is 6a. So a will be 4 meters per second square. Done? Now the next part. Only take this much part as your system or that much part as your system. If you take only this much part as your system, the forces acting are 21 Newton. From here there will be some internal reaction. It will be accelerating with the 4 meters per second square. The mass will be different. Total length 60, mass 6 kg. So per centimeter, or I would say for every 1 kg it is 10 centimeter. Correct? 1 kg is 10 centimeter. So 15 centimeter will be how much kg? It will be 1.5 kg. Yes or no, guys? Check this out. For every 10 centimeter, it is 1 kg. So definitely this will be nothing but 1.5 kg. Yes or no? So now apply Newton's law. Net force is mass into acceleration. So R minus 21 is 1.5 into 4. So this will be nothing but 6. So R will be 21 plus 6, which is 27 Newton. That is the answer. Exactly. Where is 27? Option C. So a seemingly difficult problem is easy when you make proper choices of the system. Choose the system properly. I have to find acceleration. That's why complete rod. I have to find internal force. So make these two separate. So I only took this part and solve the question. You can even take this part and solve. You will still get the same answer. Next question. A body of mass 15 kg. Read the question, guys. Is taken up from a certain depth. The work done in raising it by 5 meters is 870. The velocity is how much? Okay, guys, I won't be reading all the questions now. I would request you guys only to read it because my throat is giving up on me. I want to take lots of questions. I don't want to, stop the lecture because of my throat. So just try to read the question. Please try to answer a lot and help each other. Okay, because it's paining a lot right now. So maybe another half an hour I'll be able to take a class right now. Okay, just try to read the question. Let's try to solve this. Okay, so I have to take it up by 5 meters. The work done is this much. Okay, so if I have this mass, how much is the mass? Which is 15 kg basically, and I take it up by how many meters? 5 meters over here. By the time I take it up, it will have some velocity. I have done some work. So where and all will I use my work? My work will go in increasing the kinetic energy and also increasing the potential energy. I'm pulling it up. If I'm spending some amount of energy, Obviously, I'm giving it some speed, so kinetic energy. I'm increasing the height, so potential energy. Now, what is the kinetic energy? It will be half mv square. What is the potential energy? It will be mgh. Work is W. Work is given. How much is it? 870. Half mass is given 15. Velocity, that's, I think we have to find it. Okay, plus mass 15, g 10, height 5. Let's try to do this. 15 by 2 v square plus 15 5s are 75, so 750. So 15 by 2 v square will be 870 minus 750. So 850, 120. Yes, so this will be 120. 15 goes with 120 8 times. So v square will be 2 into 8, which is 16. So v will be 4 meters per second. Just check this out. Yep. Yes, Venkat Praman. Awesome. It's option B. Perfect. Very good, Krishna. Very good, Naveen. Excellent. Awesome. Will I take EM set classes, Ashok? Yes, I will. I'll take it, bacha, but not now, after some time. I know your board exams are going on and all of that after the board exams, not before that. Okay, moving on to the next question coming up on your screen. This is easy question. I think you will be able to do it. Which of the following is wrong? Read it carefully. Okay, it's not right. Which of the following is wrong? This is velocity. This is time. It's a graph of velocity versus time. Interesting. Look at this. Yes, velocity can be negative also. Yes, but here none of the options have negative answer, so I will not mark it. Okay, so work done. Well, here initial velocity 0, final velocity 0, initial kinetic energy 0, final kinetic energy 0, change in kinetic energy 0, work done 0. Work kinetic energy theorem. So work done is 0. Understood? Average acceleration. Average acceleration is final minus initial velocity by time. Final 0, initial 0, time whatever. So 0 by anything is 0. So hence acceleration is also 0. Average force. Average force is mass into average acceleration. Average acceleration is 0. So average force is also 0. This is also correct. Average velocity is 0. I think this is wrong, guys. Think about it. There is some area under the graph, right? This area will give you displacement. So average velocity will be displacement by time, which is definitely not going to be 0. So hence this is wrong. That's it. Very good. Velocity is not constant, bacha. Velocity is non-uniform. It is changing. It is changing because you can see that it's going up. Acceleration is there. Positive acceleration, negative acceleration. Okay. Yeah. Next question. Just give me 3-4 minutes, guys. I'll be back with the solution and everything. Just take a break of 3 to 4 minutes. I'll just drink some water, maybe gargle also, and come back. Okay. Just give me some time. I'll be back. All right, guys. So it's back. Everybody's back. Yep. There we go. Okay. So that was a short break. I was just checking how many questions are there. Hardly, maybe around 15 to 20 more questions are there. And I think we will not take much time, maybe around 40 minutes or so. So let's start. Let's go full on with full energy, full josh. Call in your friends, call in your batchmates, call in your classmates, call in all your cousins who are preparing for the JEE exam. Make sure every single friend, your acquaintance is on the channel right now live, because problem solving session is going on. And after the break, we are going to do this question now. So let's do this. Force required to move this car at constant velocity is proportional to the velocity. If the required wattage is 300 with the 9, then power required to move the car with 36 meters per second. Now, in this question, understand the main equation that you're going to use is power is force into velocity, number one. The second thing, as per the question, the force is at a constant velocity is directly proportional to its velocity. So the force is directly proportional to its velocity. That's the question. That's what is given in the question. Now in the first part, if you notice, 300 watts is equal to force into the velocity, which is basically 9. So force is basically 300 by 9, which I can call it 100 by 3 newtons. That is the force in the first case. Now, when you move the car with 36 meters per second, what will happen? When you move the car with 36 meters per second, from 9 to 36, basically the change is 4 times increase in the velocity. So because force is proportional, oh sorry, I wrote V square, my bad guys, I'm sorry, it is not V square, it is just V, my bad. If the force is proportional to only velocity, not V square, and velocity increases 4 times, obviously force will also increase 4 times. So therefore, force also increases 4 times. That means the new force will be 100 by 3 into 4. Yes or no? That is the new force. That is the new force. So what is the new power? What is the new power which is there? It will be that new force, which is 100 into 4 by 3 into the new velocity, which is basically 36. 3 goes with 36 12 times. 12 4s are 48. So 4800 watts. That's the answer. Option B. Exactly. That's the answer. Option B. So many of you said C. That is wrong. Option B is the correct one. Understood, everyone? Okay. Great. So let's move on to the next question coming up on your screen. Here it is. A truck moves up a hill, incline 1 in 30, speed 30. Resistance is 5% of its weight. The speed of the truck when it goes down with the same power, how much will it be? Interesting. So, guys, I'm just going to block some spammers out here. Not needed at all. Okay, great. So anybody else trying to spam, please understand that you will be completely blocked out of the channel, okay? So I don't want spammers out here. Next, over here, what I'm going to do is, first of all, understand what is happening in this question. Truck is going up, inclination is 1 in 30. What does all these things mean? So imagine this is your truck, which is mass M. It is going up with certain speed. What is the speed? 30 kilometers per hour. Now, resistance is there, which is 5% of the weight, meaning the frictional force is 5%. What is 5%? 5% is basically 1/20th. Yes. So basically the frictional force is mg by 20. That is what it means. Next important thing. Apart from this, understand there will be mg's component also, mg will also have two components, one component here, one component here. This will be mg sine theta component. Now what does this 1 in 30 exactly mean? It means if you go 30 units, the plane goes up by 1 unit. That is 1 in 30, inclination 1 in 30. See if this makes sense. Everyone with me on this? Everyone with me on this? Inclination 1 in 30 means when you go by 30 units, it goes up by 1 unit. This is basically your theta. This is basically your theta. Isn't theta very, very small? If you look at this figure, 1 in 30 is very, very small. Therefore, sine theta will be tan theta will be 1 by 30. So hence, if sine theta is 1 by 30, this will basically become mg by how much? Mg by 30. That's it. Mg by 30. That is the weights component. This is the frictions component or friction force which is acting. These two forces will be balanced by the force provided by the engine of the truck while going up. So over here, F1 will be mg by 20 plus mg by 30. As it goes up, this is being balanced by these two. That's why it is going up with constant speed. That is the first scenario. Understood, guys? Everyone till here? So this will just become mg by 10. You can take 1 by 2 plus 1 by 3, that will be 6, and 2 plus 3 is basically 5. So 5 goes with 10 2 times. So mg by 12 is the force in the first case. Now in the second case, there is a small change. Observe what is that small change now. Observe what is that small change. The second case, the same truck is going to go down. I do not know what is the speed. But in this case, when you are going down, you might be like, "Ha, sir, you don't even have to accelerate." No, the problem is this frictional force. This friction or the resistance is always opposing. That's why you have to press the accelerator even while going down. It's a heavy truck, so there is going to be some kind of resistance. So how much resistance will be there? Same resistance, but this time it will be this way. So mg by 20 will be this way. The component of the weight component will still be there downwards. How much will that be? It will still be mg by 30. That is still there. You can see the resistance is more, weights component is less. Mg by 20 is a bigger force. Mg by 30 is a smaller force. So the net force is here, this side. So you need to push it down, only then it will go down. So you need some force this way. So that is the force which has to be applied on the truck in order to power it downwards. In this case, F2 plus mg by 30 will be equal to mg by 20. Rather, F2 will be mg by 10 common, and this will be 1 by 2 minus 1 by 3. So this will be 3 minus 2, which is 1, 3 2s are 6. So this will be basically mg by 60. That is the force while going down. Now it is given that the power is same. That is the question's information. So if power is force into velocity and this guy is given to be constant, that means F1 into velocity 1. How much is the velocity 1? Which is 30. Will be equal to force 2 into the new velocity, which I do not know, into the new velocity. F1, how much is F1? mg by 12. Mg by 12. This is 30. This is F2, which is mg by 60 into V2. Do the math and tell me what is the answer. Do the math and tell me what is the answer, guys. Quickly. Some of you are saying 150. Some of you are saying B. Yes, that's 150 again. Yes, it is 150, guys. Yep, this is 150 kilometers per hour. That's it. That's the way you solve it. Drawing free body diagram is very important. Understanding which force acts where, very important. A new concept that you saw over here is inclination of 1 by 30, 1 by 20, whatever it is. It means sine theta is 1 by that number. And theta is small, so sine is equal to tan. That's all. Beautiful question. Systematically, if you solve it, you will get the answer. Okay, moving on to the next one. Okay, a body of mass, certain mass is given, momentum is given, constant force is given, change in the kinetic energy of the body is how much? Okay, so momentum, time, mass, force, I think just basic formulas. What is the change in the kinetic energy? Achha, kinetic energy initially is momentum square by 2m. This formula is there. So let me first find out initial kinetic energy. Initial momentum is 20. Mass is basically how much, guys? 5. So this will be 400 by 10, which is basically 40 joules. That is your initial kinetic energy. Now to find final energy, I need the final momentum. To find the final momentum, I'll use second law of Newton, which is force is change in momentum by time. How much is the force? 5. How much is the time? 10. Change in momentum, final minus initial. What is the initial momentum? 20. So this will become 50 is equal to final minus 20. So final will be equal to 70. From this, final kinetic energy, final momentum square by 2m, which is going to be equal to 70 square by 2 into mass is how much? 5. So this will become 7 square 49, 4900 divided by 10. So it will become 490 joules. But the question says what is the change in the kinetic energy. So change will be final minus initial. Final is 490, initial is 40. So this will become 450 joules. That is the answer. Where is it? Option D. Very good. Awesomeness. Many of you answered it. Very good, Krishna. Maxwell, Jivita, Jinendra, Naveen, Superstar, Venkatraman. Very good, guys. Awesome. Sir, will NEET questions be difficult as like the previous questions? NEET questions are generally easier, but in the section B, right, expect JEE Mains type of question only. So these days, JEE Mains level has gone down, correct? Everybody knows that. You would have seen all the 2020, 2019, 2021, 2022 papers, even the 2023 first shift papers. It's horrible. I mean, levels have gone down, cutoffs have lowered. So the level of JEE Mains and NEET almost similar. You can say the section B of NEET is very similar to the JEE Mains level. Section A of NEET is much simpler. Yeah, okay. Let's have a look. A particle of mass m going in a circular path, centripetal force. Question is, what is the total energy of the particle? If any particle is going in a circular path and the centripetal force is there, it will cause centripetal acceleration. This is the velocity. I can just say centripetal force is mass into centripetal acceleration. Magnitude wise it is k by r square. The minus sign just says that it is towards the center. That's all. Nothing else. So this will be equal to mass into centripetal acceleration, which is v square by r. So r gets cancelled. So mv square will be k by r. Now the kinetic energy will be half mv square. Mv square is k by r. So it is half k by r. Now in atomic structure or in gravitation or in such chapters, you would have seen, if you know kinetic energy of a particle going in a circular path, okay, orbiting because of this electromagnetic force or gravitational force, what happens? The potential energy will be twice. The potential energy will be twice of what? The kinetic energy, but with a negative sign. You would have seen this. Potential energy is twice of kinetic energy with the negative sign. Total energy, remember, which is the sum of potential and kinetic, is nothing but negative of kinetic energy. So basically total energy will be minus of this, so minus k by 2r. That's it. That is the answer. These are standard formulas which you have learned in atomic structure or satellites and all of that. So that's option B, of course. Understood? So if they had asked you potential energy also, you could have found it out. If they had asked you kinetic energy, you know that. Total energy, found it out. Awesome. Next question coming up on your screen. Yes, in modern physics. A bucket filled with water, mass 15 kg, is taken up 12 meters with a rope. Work done is this much. What is the mass density of the rope? Interesting. See, this is our rope. This is that bucket, which is 15 kg. The mass of the rope, I don't know. Length of the rope, I know. If you bring it up, what happens is the entire thing is brought on the top. So when you bring the entire thing on the top, just imagine what happens. Okay, when you bring it on the top, this 15 kg is over here. And this rope, which is there, it would be just lying there like this, whatever. Okay, so the center of the mass has gone up, not just for the rope, but also for this mass. For 15 kg mass, you have taken it up by how many meters? 12 meters. For the rope, the center of mass was here. Now the center of mass is here. So for the rope, I don't think you have taken it up by 12 meters, but you have just taken it up by 6 meters. Did you understand the catch? So even the center of mass of the rope will go up, but not by the same amount, because the center of mass of the rope is just at half the point, so it will go up only by 6 meters. But for that guy, 15 kg, it will go up by 12 meters. So whatever work you are doing is going in increasing the potential energy of the rope plus increasing the potential energy of the mass. What is the work? 2160. Potential energy of the rope, mass into G into height 6 plus mass into G into height. Okay, so this 0 goes with this G, goes with this G, because G is 10. So 216 is 6m plus 15, and this is basically 12. So this is going to be 180. So 6m will be 36. So m will be 6. But the question is not to find the mass. Question is linear density. What is linear mass density? It is mass per unit length. 6 kg mass for how much length? 12 meters. So by 12, which is 0.5 kg per meter. That is the answer. 0.5. Where is it? Option B. Yes, option B. Very good. Got it? Clearo? What a lovely question, isn't it? Beautiful question, guys. A lot of people forget to multiply it by 6. They write 12 over here. I've seen that. You will get a completely different answer. Some people don't even consider the rope. They don't understand what to do. So now you know what to do. The moment you see this kind of question, which has been asked many times, you will be able to solve it instantly. And you know half should be there. That's all. Next question. Also common question. How am I estimating it to be half, Jitendra? Because of this. Center of mass of the rope is here. No? This is the center of mass. The new center of mass will be here. So where is this? Half of 12. So 6 meters is the height by which the center of mass goes up. That's all. The rope will be just lying on the ground. No? The rope will be lying on the ground. So center of mass will be on the ground level. That's all. Is that clear now? Moving on. Next question. Force moves the body from here to here. Work done is how much? We know work done is force dot displacement, which is force dot final minus initial position. So let's do this. Work is 8 joules. Force is 4I minus 3J plus 5K. Dot final minus initial. This is final, this is initial. A minus 3. So it will be A minus 3 I cap. Then plus minus 8 minus 6 J cap plus 5 minus 3 K hat. This is what it is going to be. We all know what happens when you take dot product. I goes with I, J goes with J, K goes with K. Always similar terms get multiplied. So this will become 8 is equal to 4 into A minus 3 plus minus 3 multiplied by, what is this? Minus 14, right? Plus 5 multiplied by, what is this? 2. So this is going to be 4A minus 12 plus, rather I'll put minus over here. So minus 14 3 is 42 minus 42. plus 10. So this will become 4a and yeah, so this is, oh sorry, this is not minus guys, sorry, this is plus, minus and minus is there. So 42 minus 12, 30, 30 plus 10, that's again going to be 40. So 4a is basically minus 40 plus 8, which is minus 32. So that is 4a. So a will be minus 8. That is the answer. Just check this out. Minus 8. Minus 8. Yes, that's the answer. Perfect. Yep. Can we get under 2K in JEE Advanced if we start preparing from May? Depends, Krishna, where you are, what state you are in. I mean, what is your condition right now? All that. Okay, great. Moving on to the next one. Displacement is given by this. T is in seconds. What is the work done by all the forces from 0 to 2 seconds? Very simple question, I think. Because work done is asked, I feel rather than integrating force with displacement, because force is not given, I would prefer using work energy theorem. Just try to find kinetic energy. But to find kinetic energy, I need speed. How do I find speed? From displacement, think velocity will be ds by dt. So it will be basically 2t plus 2. So velocity at 0 seconds will be how much? 0 plus 2, which is 2. Velocity at 2 seconds will be 2 into 2 plus 2, which is 6 meters per second. I think from this I can find what is the work done. Work done is final minus initial kinetic energy. So half m final square minus initial square. Mass is how much? 1 kg. Final speed is 6. Initial speed 2. So this will become half into 36 minus 4, which is 32 by 2, which is 16 joules. That is the answer. Where is it? No, it's not 6, bacha, it is 16. Yep, that's the answer. Very good. Awesomeness. Is that clear, everyone? Everyone is clear? Very nice, very nice. Moving on to the next question, guys, coming up on your screen. Here it is. Speed of a motor goes up from 2400 to 3600 in 2 seconds. How many revolutions does it make? If you want to find the number of revolutions, you need to find how much angle it covers. If you want to find how much angle it covers, what do we do? Think, I would need acceleration, I think. Because I know the time, I think I need the acceleration. I can use this equation. Delta theta is initial velocity into time plus half alpha t square. Initial speed known. Alpha don't know. Time known. I need alpha. How do I find alpha? Okay, let's try to figure that out. Before doing that, this is in RPM converted into radians per second. So this will be 2400 rounds per minute. So per second divided by 60, and each round is 2 pi radian. So this goes with this 40 times. This is 80 pi radian per second. Yes. Similarly, this one will become 3600 divided by 60 into 2 pi. This goes with this 60 times. So this will be 120 pi radian per second. Now try to find alpha. Alpha is final minus initial by the time taken. So it will be 120 pi minus 80 pi. Yes or no? Divided by the time. How much is the time? 2. 120 minus 80? 40. 40 pi divided by 2. How much will it be? 20 pi radian per second square. Use that alpha over here. Use that alpha over here. Now do the rest of the calculations. It's going to be easy. So I'm just going to substitute everything. Initial velocity 80. 80 pi into 2 plus half into 20 pi into 2 square. So this will be 160 pi plus 2 goes cancelled, 2 into 20, 40. So 40 pi. So this will become 200 pi. So 200 pi radians is nothing but 200 pi divided by 2 pi revolutions, because one revolution is 2 pi radian. So if we divide it by 2 pi, I get the number of revolutions. So that is going to be 100 revolutions. That's all. Yep, there you go. Option C. Very good. Awesome. Many of you got it. Very good, Mohit, Shri, Harimarjanath, Krishna. Yes, it's not 200, it's 100. 200 pi, yes, but 100 revolutions. Moving on to the next one coming up on your screen. The angular frequency of a fan increases from 60 to 120 in pi by 2 seconds. A dust particle is present at 10 centimeters. What is the tangential acceleration of the particle? Let's see. Okay, so there is a dust particle, the fan is rotating, the radius is given. I need to find tangential acceleration, which is alpha r. Can I find alpha? If I find alpha, I can find 80. Okay, how do I find alpha? Okay, look at this. Initial angular speed is 60 rpm, which is nothing but 60 by 60 into 2 pi, which is 2 pi radian per second. Final angular speed is 120 rpm, which is 120 by 60, okay, into 2 pi, which is 4 pi radian per second. Time taken is pi by 2 seconds, it's given. So can I find alpha? Can I find alpha? Obviously. How? Final minus initial divided by the time. What is final? 4 pi. What is initial? 2 pi. Time is pi by 2. So this will become 2 pi by 2, which is basically pi goes, it will become 4 radian per second square. Now that I know the value of alpha, substitute it over here. So AT will be 4 into radius. Radius is 10 centimeter, that means 0.1 meter. So tangential acceleration will be 0.4 meters per second square. That's it. 0.4. Exactly. Option B. If the question said find centripetal acceleration, if, I know it is not asked, if the question was what is AC, then what will you do? AC will be omega square r. Omega, I know it is finally 4 pi. So 4 pi square into radius. That's how you're going to find it. So depending on the question, you can find different things. You should know all the formulas. If you know the formulas, you can find anything, and you should play with the problem. Acha, this was asked. What if that was asked? Ocha, what if the total acceleration is asked? This acceleration and this acceleration both are perpendicular. Find the resultant by Pythagoras. That's all. Next question coming up on your screen. Here it is. A mass of this rotated in a vertical circle. When the string makes 60, the speed of the mass is 1. The tangential acceleration is how much? Okay, let's try to visualize. Without that, it will be difficult. The string makes an angle of how much? 60 degrees, I believe, with the vertical. And the speed of the particle is how much? 1 meter per second. Okay. Now, what are the different forces acting on this? Obviously, one tension will be there. Mg will be there. Mg will have two components. One will be Mg cos 60. And the second one will be Mg sin 60. That's it. Nothing else apart from this. Because of these forces, there will be accelerations. Because it is going in a circular path, obviously there will be a centripetal acceleration. And in this direction, there will be tangential acceleration. If you notice in this direction, there is no other force apart from Mg sin 60. So therefore, in the tangential direction, I can just say Mg sin 60 is mass into tangential acceleration. So therefore, mm cancels. At will be g into sin 60, which is root 3 by 2. So it will be 5 root 3 meters per second square. You might ask, sir, what is the use of this? No use. It's just given to confuse you. There is no use of 1 meter per second. Okay? So that's all. So 5 root 3, which is option A, I believe. Yep. If the question was centripetal acceleration, if the question was centripetal, okay, it is not asked right now, but if question was what is centripetal, then you will use v square by r. V is 1, r is 15, so 0.15. So then you will say it is 15 and this is 100 100 by 15 meters per second square. That's when you will need it. For now, this question, you don't need it. Okay, moving on. A bullet of mass hits a pendulum bob of mass 3m with a speed v, comes out of the bob with speed v by 4. Length of the pendulum is given. What is the minimum speed so that the bob goes in a vertical circle? Interesting. Let's try to figure this out. Okay, so let me show the two situations. This bob is there of mass 3m. Another point mass of mass m goes with v speed. Now what happens is, after the collision, this 3m acquires a beautiful velocity of root of 5 gr. Okay, because that's the minimum speed for it to complete the vertical circle. This point mass comes out of it. This point mass comes out of it with speed v by 4. That is what is happening. This is before, this is after. Okay, this is before, this is before, this is after the collision. Why this is root 5 gr? I hope you know. For a pendulum with rope, minimum speed is root 5 gr. Okay, let's try to do this now. I can use momentum conservation, I believe, over here because it's collision problem. Okay, so we'll use momentum conservation. So conserve momentum. Mass into velocity, this guy is at rest, is equal to mass into velocity plus mass into velocity. Take that guy over here. So mv minus mv by 4 is equal to 3m root 5 gr. m goes, v minus v by 4 is 3v by 4 is equal to 3 times root 5 gr. 3 goes from this, v is 4 times root 5 gr. So what is the value of g? 10. What is the value of radius? 0.5. So this will become 10 into 0.5, 5. So it will be 5 into 5. Root of 5 into 5 is just 5. So it will be just 20 meters per second. That is the answer. Just check it out. Yep, option B, of course. Straightforward. Straightforward. Yes, Arun, it is 20. Are you guys enjoying these questions, guys? Beautiful questions. If you get into that mood of problem solving, trust me, there is no stopping this momentum. And these are the exact level of questions which is asked in JEE Mains. Moving on, next question coming up on your screen. A body moves along an uneven horizontal road surface, constant speed. The normal reaction of the body, where do you think it is highest or where do you think it is lowest? That is the question. Come on. Where do you think it is the highest? Where do you think it is the lowest? I feel that when you go like this, one is your weight, next is your normal reaction, correct? And centripetal acceleration is over here. In this case, normal minus mg, normal minus mg. Think about it, guys. Normal minus mg, what will happen? This will be equal to MAC. Yes or no? Normal minus mg will be equal to MAC. Now, from this, n will be equal to mg plus MAC. Fair enough? This is when you're going like this. If you take this situation, here normal is this way, mg is this way, centripetal acceleration is here. Here mg minus normal is MAC. So the normal will be mg minus MAC. Yes or no? mg minus MAC. Very nice. Now think carefully and tell me, where is the normal more? Here or here? This is mg plus, this is mg minus. Obviously this is lower normal or lesser normal. This is larger normal. So where is the normal higher? It is going to be max over here, max over here, but here at B it will be minimum or less. Hence the answer will be maximum at A. Where is it? Option A. Maximum at B? No. Minimum at B. Minimum at C? No. Maximum at C. Same? Definitely not. Now let me tell you that exactly similar question I have put it later on, okay, but here it's with values. I would ask you guys only to solve it, okay. I'm not going to solve it over here. It's very similar, same equations, same data, just that values are given. Speed is given, radius is given, what is the ratio of the normal force. I feel you can solve this. Okay, everyone, cool. Let's go to some PYQs. Are you ready for some PYQs coming up on your screen? I can't shout, guys, so you might feel that my energy is low, but trust me, it is not low. I'm mentally very energetic, but I just can't talk loudly. Not forget loudly, even normally. Okay, chalo, let's go to PYQs. What is this? The velocity is given of the bullet, which becomes 1/3 after it goes 4 centimeters inside a block. Assume that it faces constant resistance and it stops inside. What is the value of x? Okay, let's visualize this. This bullet, okay, it's going with some speed, and the velocity becomes 1/3 after it penetrates by 4 centimeters. Okay, that is what is clearly given in that particular question. Okay, so imagine the velocity is v. After going 4 centimeters here, velocity has become 1/3. Let me also think about kinetic energy. If kinetic energy was k over here, what will be the new kinetic energy? Think logically. Think logically, guys, and tell me in the chat box. If initial kinetic energy was k, what will be the kinetic energy after traveling 4 centimeters? After traveling 4 centimeters, what will be the kinetic energy? Obviously, kinetic energy is half mv square. So velocity squared is there. Velocity becomes 1/3. V square will become 1/9. So hence it will become k by 9. You might be wondering, sir, why are you taking kinetic energy? I think it will make the job easier. I'll tell you why. See, when you go from here to here, some work is being done by the resistive force. The resistive force is there, no? The force is there. The work done by that force will be final minus initial kinetic energy. Let me use that and solve the problem. It will look very easy. No need of kinematics, no need of Newton's laws and complex questions or equations. It will be very easy. What is the work done? Force into displacement, which is 4, with a negative sign. Why negative sign? Force and displacement are opposite, obviously. Final kinetic energy, k by 9. Initial kinetic energy, k. So this will become 4f is equal to k. 1 minus 1 by 9. I have taken the minus sign over there. 1 minus 1 by 9 is 8 by 9. So it will become 8 by 9 of k is 4f. So 4 and this 8 gets cancelled. So f is basically 2k by 9. I got the value of the force in kinetic energy. But that's not the end story. See, eventually what happens is it travels more distance x and finally it stops over here. The force continuously acts. So if I take the entire journey, look at this, entire journey, then if I use the same equation here, work done by the force will be force into displacement, which is 4 plus x, but with a negative sign. 4 plus x, total displacement, yes, is equal to final energy 0, initial energy k. Interesting. What is the value of force? Force is 2k by 9 into 4 plus x is equal to minus k. Minus minus k gets cancelled. So 2 by 9 into 4 plus x is equal to 1. So 8 plus 2x is equal to 9. So 2x is basically equal to 1. So x is basically equal to half. Done. Where is it? 0.5. Answer is found so easily. So using work energy, you can solve these bullet entering into a block questions in a much simpler manner than using kinematics, Newton's laws and multiple equations. Did you understand? Great. Moving on to the next one. The question says it's a conical pendulum. The angle made is 45 degrees. Circular motion. If the radius of the circle is given, center is right below the point O, what is the speed of that particular pendulum? Very simple. I'll tell you what to do. See, there will be tension acting in the string of that conical pendulum. Weight will be acting downwards. The centripetal acceleration will be here, correct? This will be component of tension here and component of tension there. So if I take this as theta, which is also 45 degrees, can I not say in the y direction T is cos 45 is mg down, tensions cos 45 up is mg down, correct? That also in the x direction, tension's component is giving the acceleration. So tension sine 45 is equal to mass into centripetal acceleration, yes or no? So divide both of them. So if you divide y by x, what do you get? Cos 45 and sine 45 are same, tt are also same, so hence you will get 1. Here m will get cancelled, I'll get g by ac. So AC is equal to G, V square by R is equal to G. Therefore, V is root RG. What is radius? Radius is 0.4. What is G? It is 10. So it is root of 4, which means it is 2 meters per second. That is the answer. Exactly. See this? That's it. Simple. So, simple Newton's laws, drawing free body diagram, resolving the components, understanding which applies where, and just writing the equations. That's all. Yeah, I'll be finishing it in the next 10-15 minutes only, bacha. Don't worry. Yeah, mine, okay. Okay, don't worry. I know chemistry class is going to be there, and yep, it will be done much before that. A block of mass 2 kg moving at the horizontal surface with a speed of 4 enters a rough surface. This point to this point. The rough force frictional value is minus kx. K is some constant. What is the speed as the block just crosses the rough surface? Let's try to understand. See guys, imagine this is that rough surface over here. This is x equals to 0.5. This is x equals to, this is 1.5. This is 1.5. So in this part, what happens is, if the block enters with certain speed, what is that speed? 4 meters per second. 4 meters per second. By the time it comes out, it will have a reduced speed because of the friction. Because of the friction. So that force which is there, minus kx, that will suck away some energy. So definitely the work done by that friction or that resistive force is sucking away the kinetic energy. So why not use work kinetic energy theorem? So the work done by this particular force, which is basically minus kx into dx, integration. Why integration? Because work done is integration of force with respect to displacement. If you don't want to miss a step, no problem, I'll write it down. Integration of f dx from 0.5 to 1.5 will be half m final velocity square minus initial velocity square. Let's substitute everything and see what do we get. Force is minus kx, so minus k outside, integration x dx from 0.5 to 1.5 is equal to half mass 2 kg. Final speed, I don't know. Initial speed, 4. Put it over there. So what will this be? Okay, so this will be minus k and x square by 2. So x is, is the value of k given? Yes, the value of k is given to be 12. So 12 into x square by 2 is the integration. So 1.5 square by 2 minus 0.5 square by 2 is equal to 2 cancels. So vf square minus 16. Now this 2 goes with 12. This 2 goes with 12. It will become minus 6 into 1.5 square is 2.25. This will be 0.25 is equal to vf square minus 16. Next step, observe carefully. 2.25 minus 0.25 is 2. 2 into 6, 12. So this will become minus 12 is equal to VF square minus 16. Therefore, VF square will be 16 minus 12, which is basically 4. So VF will be 2. That's it. So is 2 there somewhere? Option C. Yep, there you go. 2 is the answer. No, it is not 1.5. Just again, it is 2. Hello Maya Deshvi. Yes Arun, very good. Yes Krishna, that's the correct answer. Proud of all of you. Moving on to the next question coming up on your screen. There is a motor, lifts an elevator, total load given, frictional force given, speed at that full load is how much? Okay, let's draw, understand. Without drawing, we should generally not proceed. This is that elevator. How much is the mass? 2000 kg. 2000 kg. It has to be pulled up. Why it has to be pulled up? Because of the weight and because of the frictional force. So if the elevator tries to go up with certain speed, obviously the resistance will act down. The resistance is how much? 4000 Newton. 4000 Newton. And the original weight will also be there, 2000 G. Do not forget that. So the tension in that cable, which will be provided by the motor's force, the motor will be giving that tension, it will be pulling that rope up, because of which the lift goes up. Can I not say tension will be equal to the weight plus friction? Weight is 2000 into 10 is 20,000. So 20,000 plus friction is 4,000. So this will be 24,000 Newton is the tension. But that's not the question. The question is, what is the speed of the elevator if the power of the motor is given? We all know power is the force into velocity. The force is because of the tension. That power is 60 horsepower. Horsepower is 746. 1 horsepower is 746 watts. So 60 horsepower is 60 into 746 watts. So this will be equal to 24,000 into V. You can cancel this. 6 goes with 24 4 times. So 400. So 746 divided by 400 is equal to V. So I think it will come out very close to 1.9 or something. Yes, that's the answer. So this velocity close to 1.9 meters per second, because 400 into 2 is 800. So it's slightly less than 800. So slightly less than 2. So 1.9. Yeah. Is that okay? That's the answer. Perfecto. Perfecto. Moving on to the next question. When a rubber band is stretched by a distance, the restoring force is given by a variable force as this function. Work done in stretching that rubber band by L, not unstretching guys, this, by to stretch it by the distance L is how much? See, whenever force is a function of x, work done will be integration of force with respect to dx. So just have to integrate this function, nothing great about this. So just integrate ax plus bx square dx from 0 to L. That's the total extension. So x's integration will be x square by 2 from 0 to L plus b into x cube by 3 0 to L. So when you substitute the limits, it will become al square by 2. This will become bl cube by 3. That's the answer. Very easy. Easy peasy lemon squeezy, right? This was. See, so many people giving the answers. Perfect. Oh my God. See, now I know at least so many people are there. Suddenly people have started answering. Otherwise, people were very silent and quiet. Oh my God, what will sir think? What will others think if I give the wrong answer? Don't worry guys, it's okay. If you give wrong answers now, that means you are learning. Make as many mistakes as you want right now, because you don't have that luxury to make a mistake in the examination hall. That's it. This is your final JEE Mains attempt. That's it. After this, those scores are scaled unless you take a drop. And I don't want you to take a drop right now. Okay, because there is a good chance that you can go up to 99 percentile if your scores are less. Okay, so moving on. Next question coming up on your screen. So what is this question now? Body of certain mass moving in a medium, frictional force, speed is given, after 10 seconds, energy is 1/4. What is the value of K? Okay. Now, after 10 seconds, the energy becomes 1/4. Mass is also given. Initial speed is this much. Okay. See, if energy becomes 1/4 and energy is half mv square, therefore speed will become how many times? Kinetic energy is half mv square, correct? Energy has become 1/4. So v square has become 1/4. The square of the velocity has become 1/4. So v would have become how many times? Half times? Very good. Half times. Awesome. So what is the new velocity? It is v1 by 2. That means 10 by 2, which is 5 meters per second. I just kept it on the side. I don't know whether I'll need it or not. Force is given. Achha. Now from this, what can we do? Can I say that force is equal to mass into acceleration? Yes, of course. Force is minus kv square, but I don't have velocity here, so why not write it in the differential form, dv by dt. Now I know what to do, it's just integration, that's all. So this will become minus k by m v square, all right, wait a minute. I'll just put it like this, take v square on that side, okay? So I'll have minus k by m dt over here is equal to v raised to minus 2 dv. So now just substitute everything. What is the value of k? In fact, that's what we have to find out. What is the value of m? 10 to the power minus 2. Okay, integration dt. So integration of dt from the limits 0 to 10 is equal to integration of v raised to minus 2 dv from the limits, look at that, from 10 to 5. That's it. Now do the math. So this will be minus k and the 100 will go on the top. 100 will go on the top. 10 raised to minus 2 is 100 on the top. So minus 100k. This will become 10 minus 0 is equal to v raised to minus 2's integration is v raised to minus 1 by minus 1. So this is just negative 1 by v. So 1 by 5 minus 1 by 10. That's all. Now do the math and tell me guys what is the value of k that you are getting. Simple. Abhishek, another 5-10 minutes, not more than that. Yeah, what is the value of k that you are getting guys? Just solve this and tell me. See if you are getting as 10 to the power minus 4. If you are getting 10 to the power minus 4, very good. That's it. That's the answer. Are you guys getting it? Yes or no? Just try it out. Don't just say, yes sir, we got 10 to the power minus 4 or option A. Just as Jane got it. Very good, Arun. Everybody else, try it out. Try it out. Calculate on your own. Use your brains. See if you are getting it as 10 to the power minus 4. 1 by 5 minus 1 by 10 is basically, again, 1 by 10. Yep. So minus minus goes. So you should get this as 10 to the power minus 4. Yes, very good. Perfecto. Next, a stone of mass m is tied to a string, is being whirled in a vertical circle. Uniform speed. The tension is same everywhere. Minimum at the top, minimum at the bottom, minimum when the rope is horizontal. Very easy. Where do you think the tension is the least? I think over here, if you notice, the string can become slack. Here the tension is least. Here the tension is maximum. If the string has to become slack, it will become slack here first, not here. So whenever you solve for critical situations, you always try to solve it for this condition. If it doesn't become slack here, it cannot become slack anywhere else. Because as you go down, it gets more tension. As it goes up, tension becomes least. So tension is going to be the minimum at the highest point. Very good. Option B. Great. Now is your daily practice problems. This is a special assignment sheet which is given to you daily when you attend classes here. The link will be shared on the Telegram channel. The PDF will be shared on the Telegram channel. Make sure you're a part of it. The short notes link is there on another Telegram channel. Make sure you check that out as well. Okay, all these questions are basically your daily practice problems. Just have a look at it after the session is over. Okay, So I hope you guys enjoyed today's class. Have a lovely time ahead. Have your lunch and see you in the chemistry class. Tomorrow, I'll see you for center of mass, collisions and rotation at 10:30 sharp. Bye bye. Hasta la vista. Captain Shreyas signing off.